Alright, so welcome to your first database section of the Full Stack Web Development course. We're going to start out with one of the most popular types of database management systems, and that's MySQL. So MySQL is an open source relational database system, and it's one of, if not the most popular of its kind. Now, a lot of what we do and talk about in this section is going to pertain to most relational SQL-based databases. For instance, in the next section, we'll be looking at Postgres, which is also a relational database. So a lot of what we learn in this section can be used in that one as well. All right, MySQL can be used with many different programming languages. We've already used it with PHP back in the PHP section, but it can also be used with languages like Ruby, C, C++, Python, and many more. Now, like with most relational databases, the data or the records are stored in a table, and a table is made up of columns and rows. It's almost identical to a spreadsheet in terms of what it looks like. We have columns at the top and then rows of data in those columns. MySQL obviously uses the SQL language, which stands for Structured Query Language. And this is a language that's dedicated to working with databases. All right, I'm not going to talk too much about that right now because we do have a lecture that's dedicated to the SQL language. All right, so let's take a look at some of the advantages of working with MySQL. So MySQL offers high performance, and it uses a unique storage architecture that allows databases to be configured for specific applications, which gives us better performance results. Okay, it uses memory caches, full text indexes, and other performance enhancing solutions. It also has high availability and data integrity to minimize any downtime. There's also additional solutions that can be used like MySQL cluster and MySQL replication to even further reliability and availability. MySQL also offers security features that can ensure absolute data protection. Only authorized users get access to certain databases. SSH and SSL are supported, and many other security features. Ease of use is another great advantage. Like I said, MySQL is the system that most developers learn how relational databases work, at least in my experience. It's really simple to get up and running, and it also has a really clean syntax. There's also great support and documentation available. MySQL.com has a ton of examples, tutorials, and support available. There's also a huge community of developers and administrators that are willing to help anyone that asks. Okay, many different forums across the internet. And finally, MySQL is open source and free. Okay, a lot of corporations are hesitant when it comes to releasing open source software, but MySQL is able to do so and still provide great support. All right, so there's a couple small disadvantages of MySQL. It does have some minor stability issues. According to DigitalOcean, MySQL tends to be a little less reliable than some of its peers. The issues mostly pertain to references, transactions, and auditing. So any projects that will use these features should just look into it a little more. The next one is scalability, and this isn't really unique to MySQL. It's relational databases in general. It can be kind of challenging to scale past a certain point. Some other types of databases like NoSQL are much easier to scale. Deployment has also been a bit laggy compared to other systems. This has been mostly since Oracle purchased it from Sun Microsystems. There's only been one major release in the past several years or so. And then finally, there's some limitations with MySQL. Like any software or technology, it's not built for every situation imaginable. It's not fully SQL compliant, and there can be some limitation in areas like data warehousing and fault tolerance. So the requirements for MySQL, it is cross-platform, and you can use it with Linux, Unix, Solaris, Windows, Apple. The CPU recommendation is at least a dual core, 2.0 gigahertz or better. 20 gigabytes of hard drive space plus, and then at least 2 gigabytes of RAM. All right, so you can run MySQL on a very, very low-end system. All right, obviously it's not going to give you, great performance, but you can in fact run it on older, low-end machines. All right, so there's a ton of MySQL tools available. Of course, it has its own client, its own command line interface. PHPMyAdmin is one we'll be using. That is a web-based GUI. We can create tables, run queries, pretty much do anything, and you can do it within a GUI. It's not command line based. MySQL Workbench is another one. I've used that quite a bit. Nice diagramming capabilities. SQL Pro, Heidi SQL, and MyDB Studio are some other ones. I haven't used these personally, but I have heard good things about them. And there's a lot more as well. Alright, so we briefly looked at MySQL and what it is, some of the advantages, disadvantages. Now we're going to look more at the structured query language that MySQL runs on. So SQL, as I said, stands for Structured Query Language, and it's a programming language that was designed to manage stored data in a relational database management system. Okay, SQL is defined as declarative programming. It uses the declarative paradigm, which is basically a language that uses code to express the logic of computations without describing its control flow. It also has some elements of procedural programming using procedures and routines. SQL is not something that only works with MySQL or was built for MySQL. There's actually many database systems that support SQL, such as Postgres, which we'll also be looking at in this course. All right, SQL is based on relational algebra and tuple relational calculus. And as far as its scope, it includes data insert, query, update, and delete. Okay, it has a ton of different expressions and operators, which we'll be looking at throughout this section. So some of the language elements, we have clauses, which are constituent components of statements and queries, and these are sometimes optional, so something like a where clause. Expressions, which can produce scalar values or tables consisting of columns and rows. Predicates, which specify conditions that can be evaluated to true, false, or unknown, and are also used to limit the effects of some statements and queries or to change program flow. Then we have queries, which are used to retrieve data based on a specific criteria. And then a statement is all of this together, which may have a persistent effect on the database schema or may control program flow, connections, sessions, or diagnostics. So here's an example, a labeled example of a statement. So here we have the update clause. We're saying we want to update the table country. And then here we have a set clause. We want to set the population equal to this expression, which is population plus 1. Okay, that's considered an expression. Then we have our where clause. We're saying where name, where the column name is equal to the string of USA, which is considered an expression. All right, so this part here is considered the predicate, and then all of it is a statement. Okay, so that's an example from the MySQL documentation. Alright, so when we create our tables, we can define a primary key constraint. So this will uniquely identify each record. Okay, primary keys must contain unique values and they cannot contain null values. Most tables should have a primary key, although they're not required, especially if you have some kind of junction table or relationship table, they're not required. And then one table can only have one primary key. Alright, you can have multiple foreign keys, which we'll get to later on, but only one primary. Now we can also set a field to be auto-increment, and this allows a unique number to be generated when a new record is inserted into a table. So for instance, let's say we have a table and the last the very last record that was inserted has an ID of 5. Well, if we go and we insert another record, it'll automatically be 6, okay, and then 7, 8, and so on. And this is only if the field is set to be auto increment. All right, and this is usually added to the ID field of a table, but of course you could call it anything you want. It doesn't have to be called ID. All right, and it'll increment by 1 by default. And you don't need to specify an ID when you do your inserts. Okay, so that's a really nice advantage, is you don't have to worry about creating an ID. Alright, we can also set a default constraint, and this is used to insert a default value into a column when it's created, and this will be added to new records. So in this example here, we're creating a table called test with an ID and a city field, and we set for city a default of New York. So that means that when we insert a record, if we don't specify what we want the city to be, it'll be New York. That'll be the default. Alright, and you can also set a timestamp as a default as well, which is really nice if you want to get the date and time of when the data was inserted without having to actually define it in your code. Alright, so let's take a look at some common operations and queries. These are just the most used. We have select, which will fetch records, and this has no persistent effect on the database. It's not going to change anything. It's just used to grab the records and display them. Insert will obviously insert new records. Update will update records that already exist in the table or in the column, and then delete will delete records. Alright, and then we have some common clauses and operators, such as where, which will limit rows returned by a condition. Alright, so we can specify, for instance, select name where ID equals 5. So then it will return the name of the record that has the ID of 5. Join will combine rows from 2 or more tables. Like excuse me, is used in a where clause to search for a specific pattern. Okay, this is used in searching, for instance. In will allow us to specify multiple values in a where clause, and then between will select values within a range. Alright guys, so there's a lot of different ways that we can get MySQL up and running on multiple platforms. We happen to be in Windows, and we could use the MySQL installer from the official MySQL website, but I want to install XAMPP or XAMPP, and we actually did this back in the PHP section if you've been following along. XAMPP gives us an Apache server, PHP, and MySQL. Okay, technically it's MariaDB, but it's a drop-in for MySQL, so everything is the exact same. It's fully backward compatible. And it also gives us PHPMyAdmin, which is a really nice web-based GUI tool that allows us to interact with our database visually through a GUI, through a graphical user interface, but also gives us a command line option, which is mostly what we'll be working in, because the goal is to learn SQL. So I think that's a better option than to just work in the command line, so that's what we're going to do. You want to go to apachefriends.org, and we're going to download for Windows. Okay, I'm actually not going to save it because I already have it downloaded. So just download that and then open it up. Alright, you might get this this warning about your user access control system and some conflicts, but I've never actually seen any issues with that. So we're just going to click OK and then go through the installer. Now there's a few different components that we don't need here, so we're going to keep Apache and MySQL. I'm going to uncheck FileZilla, Mercury, and Tomcat, and then I'm also going to uncheck Webalizer and Fake SendMail. Okay, we don't need those, so we'll click Next. C drive, XAMPP folder, that's fine, and click Next again. It's just going to open up this bitnami.com website. We can just close that out and then click Next, and it should go to proceed to install. Alright, so that's all set. Now it's going to ask if we want to start the control panel. I'm going to uncheck that and click Finish. And the reason I didn't start it up there is because we want to run it as an administrator. So if we go to the C drive or wherever you installed XAMPP, and then just go to this XAMPP control exe and then click run as administrator. Alright, so you should get something like this. Alright, now we could start it from here, but before we do that, I just want to install it as a service. So we're going to click this red X, and if you can't click this X, that means that you didn't run this as administrator, so make sure you do that. Alright, we'll also install MySQL as a service, and let's start up Apache, start up MySQL, and we should be all set. Alright, so let's see if we can go to localhost/phpMyAdmin. And there we go. Alright, now notice down here we're getting an error message, or a warning at least, that says we're connected as root with no password. So we want to fix that. We want to add a password to our root account. So if we go to user accounts and then go to let's see, where it says root and localhost, see how it says no password? We want to edit privileges and then click on change password and then just add in a password here. Alright, then we'll click go, and now when we try to go back, we're going to get booted out. Alright, so to fix this, what we need to do is go to our C drive. Let's see, C drive and XAMPP, and then phpMyAdmin, and then there's a config file, which is right here, config inc php. So we're going to go ahead and open that up. Alright, now in this file, if we go down to right here where it says password, you'll see it's blank. You just want to put in the password that you just created. Alright, so we'll save that, and let's go back and reload, and now everything's all set. Okay, we can now get in. Alright, so in the next video we're going to start on SQL. Now we can easily create databases from here, and we can add tables easily through this interface, which I'll get to later, but what's important is that you learn how to actually write out queries and stuff. So we can use this command line interface here to do that. Alright, so I will see you in the next video. Alright guys, so now we're going to start to work on our database. So we're going to build an online store database. We're not going to focus on the front-end application or programming or anything like that. We just want to build the structure, the data structure. Alright, so we're using phpMyAdmin, which is a graphical tool, and we can easily create tables and fields and stuff through the graphical user interface, but I want to get you familiar with SQL, so that's what we'll mostly be dealing with, is SQL commands. So if we click on the SQL tab right here, it'll take us to command window, and in here we're going to say create database, and we're just going to call this, we'll call it my store. Alright, and let's make this a little bigger, and I'll go ahead and click go. Okay, so it gives us a success message, and now over here you can see we have my store. Now all the commands that I'm running you could just as well run inside the MySQL shell or any other client really. Alright, so the platform, the phpMyAdmin system we're using is irrelevant when we're talking about SQL commands. You could run these from anywhere. Alright, so let's go back. Actually, let's click on the My Store database. That way we're actually using that particular database, and then click on SQL in our menu here. Alright, so you can see we're in that current database. Now, first thing we're going to do in this database is create a customers table. So we'll say create table, and this doesn't have to be in caps. It's just preference. I like to keep my statements in uppercase. Alright, so but it's not required. So let's create a customers database. I'm sorry, table. Now inside here we want to create all of our fields. So let's say we want an ID. That's going to be an int. And let's say it's going to be not null. And we also want this to be auto increment. We want it to increase or increment as we enter records. Okay, so to do that we can say auto underscore increment. You can see there's a little code drop down here that we can select from. Alright, in addition to the ID, let's do first name. And now as far as your formatting for your field names or your column names, you can use underscore like this. Some people will use the camel case like this, or even uppercase in the beginning as well. But we're going to stick to the underscore method. Okay, so we'll say every time there's more than one word, we're going to separate it with an underscore. Alright, so first name, that's going to be a variable character or a varchar. And then we just want to say that the max for this will be 255. Alright, and let's just copy that. Alright, so let's make this one last name. Okay, then we'll do email. What else? Let's do... We would probably have a password if this is an online store. Okay, let's also do an address or street address. Okay, we'll add a couple more here. So street address, then we'll do city, state, and zip code. Okay, so that looks good. Now we want to let the system know which one of these we want to be our primary key, and we want the ID to be the primary key. So down here, let's add on primary key, and we want to say ID. Alright, so that should do it. Let's go ahead and click go. And looks like it went okay. And if we look in my store, you can see we have a customers table. If we click on that, there's no data in the table, but if we click structure, you can see all of our fields. Alright, and everything is a varchar aside from the ID. Okay, and you can see the ID has a little key next to it telling us it's the primary key, and it's also auto increment. So now what we want to do is we want to insert some data into these fields. Alright, so let's go back to our SQL tab here. Now notice we have this columns thing right here with all the different fields, and it pre-filled this with a select statement. That's because right now we're in the command line window, but we're also inside of the customers table. Alright, that's why we're seeing this format. I actually don't want to be inside of a certain table, so let's click on this database my store and then click SQL, and now we're just in the general database, not inside of a specific table. So now we want to do an insert, so we're going to say insert into, and then the name of the table we want to use, in this case customers, and then inside our parentheses here we need to specify the fields that we want to add, data to. So let's say first name, last name, email, what else? Password. Let me just open this up in another window. Oh no, I can see them right here. Alright, so we get first name, last name, email, password, street address, city, state, and zip. I think that's everything. Alright, now notice that I'm not putting the ID, because the ID is auto increment, so that's going to get inserted automatically. Now what we want to do is go outside of our parentheses and then say values, and then open another set of parentheses, and we want to insert the data that we want. Alright, so we're going to go in the same order that we did here. Alright, so let's go and let's say first name, we'll do, I'll just put my name. Okay, first name, last name, email, password. Normally you would have your whatever programming language you're using, you would have that encrypt your password so that it's not a plain text password like this, but we're not going to worry about that now. Okay, street address, we'll say 20 Main Street. This isn't my actual address, by the way. City, we'll say Boston, Mass, and then the zip code, we'll say 01294. Alright, so let me just make sure that this matches, it's in the correct order. Alright, and notice I have quotes around these because they're all strings. They're all text strings. So let's put a semicolon there and we'll click go. Okay, so it says one row inserted. And now if I click on database my store and then click on customers, you can see that our record is now in the database. Alright, and we could edit it from here if we want, and we can do all kinds of things through the GUI, but we're not going to do that. We're going to just stick to the command line or the SQL queries. Now we can also insert multiple records in one query. If we go to SQL, and this is pretty long, so I'm going to paste it in. Alright, so you can see here we have 6 more customers, and all we did was we specified insert into customers, all the fields, and then values, and then we just have some parentheses with all our fields, and we just separated these with a comma. Alright, so let's go ahead and click go. And now if we go to our customers table, you can see we have all these different customers added. Alright, so in the next video we're going to look at ways that we can query this data. Alright guys, in the last video we went ahead and created a database, a table, and added some data. So now we're going to go ahead and we're going to run some select queries. Alright, so let's go to SQL, and for now let's just do select, and we're going to use this asterisk here, and this represents everything. So we want to select everything from, and then we want to put in the table name, so let's say customers, and let's end that with a semicolon, and click go, and now you can see it's doing just that. It's getting everything, it's getting all of the data, all the rows, and returning it back to us. Alright, and this is why I wanted to use PHPMyAdmin, because you can see our result is very clear. We can see all the different fields and all the data, alright, rather than in a little command line window. So that's selecting all from customers. So let's go back. Now, in addition to selecting all, of course, we can specify what we want to select. So if we say select first name, last name from customers, and we click go, now you can see we get our results, but we're only getting the first name and the last name. Okay, we're not getting any of the other data. Now, up until this point, we have been getting everything, all the data, whether we're just getting some of the columns or all of them. So what if we want to limit it to a certain condition? Alright, so let's go back and let's do, we'll say select all from customers. Now if we want to specify a condition, we can use the where clause. Okay, so we'll say where, and let's say we want where state equals MA. Alright, so let's try to run that, and we're getting an error, and that's because I think this needs to have quotes like that. Okay, so now it's giving us the customers that live in Mass. You can see I had two of them from New York, and those ones aren't coming up. Alright, and just as well, if we wanted to search for, let's say, a specific user with a specific ID, then we could say select all from customers where ID is equal to 2. Alright, and now you can see that's only giving me John Doe because his ID is 2. Now we can use other operators aside from the equals. For instance, let's say we want select all from customers, and we'll say where ID is greater than 3. Okay, so instead of equals, we can use the greater than operator. Click go, and you can see we get everybody with an ID 4 and higher. Alright, and that's particularly useful with things like money. If you have transactions with balances, things like that, that can come in really handy. Alright, and just to quickly show you some of the different operators, let me bring this in. Alright, so this is from w3schools.com, and you can see we have equals. We can use not equal, so this less than, greater than, less than. We can also do greater than or equal, less than or equal. And then we have these three here. We have between, which is between an inclusive range, like, which we can search for a pattern, and then in, which allows us to specify multiple possible values for a column. Alright, so let's take a look at these three here. So we'll go back to our SQL window, and we'll say select, let's say we want the email from customers, and we'll say where ID is between 2 and 4. Alright, so let's see what that gets us. Actually, we'll get the ID as well. Alright, so let's go ahead and click go. And there we go. So we have customers with the ID of 2, 3, and 4. Alright, so that's between. Now let's take a look at like. Let's actually take a look at the data real quick. Alright, so let's say we want to get all the cities that start with the letter B, or we want to get data from everyone that lives in the city that starts with the letter B. Alright, so let's go and say select all from customers, and then we'll say where, let's see, where city like, and then inside quotes we're going to say B, and then percent symbol. Alright, actually let's make that an uppercase B. So click go, and now you can see we get everybody, Boston and Brooklyn. Okay, so those are the cities that start with B. So you can do patterns. It doesn't have to just be one letter. Okay, it could be anything. So let's say, we'll say select all from customers where city like, and let's say BO percent. Okay, the percent is the wild card. So we're saying where it's BO anything. Okay, percent can be anything. And you can have a percent on both sides as well. Alright, so let me just copy that So I have to type it back out. And then we'll click go, and now you can see we're only getting from Boston because it's BO. Okay, Brooklyn would be BR. Alright, so if we say, let's put a percent and then an O and then another percent, this is going to get cities that just basically that have an O, okay, no matter what is before or after it. Alright, and you can see Boston and Brooklyn is what we're getting. Okay, so that's like. Now we also have in, and what in does is it allows you to easily have multiple values in your where clause. Now we could do this without in. Let me show you that way first. So if we say select all from customers where, and let's say where city is equal to Amesbury, and then we're going to say or city is equal to Salisbury. Okay, so let me just copy that, and then we'll run it. And now you can see we're getting all the records who are in either Salisbury or Amesbury. Now this is fine if we're just searching for 2 cities, but imagine that we're searching for, let's say, 10 cities or 20 cities. Alright, so that will get quite long. So let's go back and paste that in. Alright, so we'd have where city equals something or city equals something and so on. So in allows us to shorten that. So instead of doing all of that, we can say where city in, and then open up a set of parentheses, and we'll say Amesbury, Salisbury, and you could just keep going on. Alright, so if we run that, we get the same result. Alright, so we're going to go ahead and stop here, and we will continue in the next video. Alright guys, we're going to get into multiple tables and joins soon. I just want to touch on something real quick. So I want to look at distinct, I want to look at aliases, and concat. Okay, these 3 things, and this will be really quick. Alright, so we're going to go to our SQL window here. And what distinct does is it does just that. It returns a set of distinct values. So if I were to say select city from customers, and we ran that, it's going to give us just each record, just the city. But you can see that we get repeating values here. Salisbury twice, Boston twice. So to get just a list of cities with no repeats, we can just add in here. Whoops, I don't want to do that. We can just say select distinct city from customers. Okay, so if we go ahead and run that, it's just going to give us each city once. Alright, so that can be kind of useful. Now we also have aliases, which allow us to basically format the returned column names in a nicer way. Alright, we can also use aliases within our queries. So let's say we want the first underscore name to be formatted a little nicer. So we can use this as keyword, and then we could just say first name or something like that, but if you want to use a space, which I do, I want to format it like that. You can see that we're getting an error now. If we want to use spaces, then we can just use quotes around it like that. Alright, so we'll take first underscore name as first name, and then last underscore name as last name from customers. Okay, we'll run that, and now you can see that the column names are formatted nice and neat. Alright, now we also have concat, which allows us to basically combine columns. So if we say select concat, and in here we'll say first name, put a comma here, and then let's put a space, and then last name, and let's make that as name. Actually, I'm going to put that in quotes as name. All right, and then we'll do another concat. And let's say street address. Then we'll do that, and then city, and state, and we'll do that as address. Okay, and then we'll say from customers. Alright, so let's see what that gives us. So now if we go down here, you can see that we have just two columns here. We have name, which concats the last name to the first name, and then address, which concatenates the street address, the city, and the state. Okay, so we can easily combine different results like this, different columns. All right, so I just wanted to touch on those things before we move on to joins. All right, guys, in this video, we're going to look at updating, deleting, and also altering tables with alter table. So first thing we'll do is update. Okay, so in our customers, let's say we had someone get married. Let's say that Janet got married. Her last name is no longer Thompson. Let's say she married Kevin, so she's going to be Janet Smith. So we need to update that record. All right, so let's go to our database, MyStore, and then SQL. And we're going to say update, and then the name of the table. So update customers. And let's actually go on the next line, and we're going to say set last name equals Smith. And we could put a comma here, and we could edit other fields as well, but we just want to update the last name. And then down here, we'll just use a where clause. And we'll say where ID equals, and let me see, I forget what ID she was. She's ID 4. Alright, so where ID equals 4. Alright, so update, name of the table, set. You want to set the fields you want to set, and then add the where clause. So let's click go. Alright, and then we'll go back to our customers, and now you can see that Janet is now Janet Smith. Alright, so pretty simple. Now let's say that Stephanie is no longer a customer, so we want to delete her. She has an ID of 7. So let's go to our SQL window, and we're going to say delete from customers where ID is equal to 7. And that's it. Click go. Now if we go back to our customers, you can see that the customer with the ID of 7 is now gone. Now, what if we wanted to add a column to an already existing table? So let's say, for instance, in customers, we want to add a balance field, okay, or a balance column. So let's go to our SQL, and we're going to say alter table customers, and then we'll say add, and then the column name, so let's call it balance, and then the data type. Okay, so we'll say varchar 255. Alright, let's go ahead and run that. Okay, successful. So now if we go and we look in customers, you can see we now have a column called balance, and anything that's in it currently is going to be null because we haven't added anything to any of the balance column. Alright, it's just all null. So if we want to remove a column, we can easily do that too. It's actually going to be the same thing, except instead of add, it'll be remove. So alter table customers, and then you would say remove, and then the table name of balance. Alright, but I'm actually going to keep balance. So I'm not going to actually run it, but what I do want to do is change the data type. I set it as a varchar, but I actually want to set it to a float. So instead of add or remove, we're going to say modify column, and then the column name, which is balance, and then the data type, which we want as float. So let's click go, and let's take a look. Okay, it's still null, but if we click structure, you'll see balance is now a float. Okay, so that's how you can alter tables or alter columns. Now let's say we want to add a balance for somebody. So we'll say update customers, and we'll say set balance equals 500 where ID equals 1. Okay, let's take a look at that. And now you can see the user with 1 has a balance of 500. Alright, so that's how we can update, delete, and alter tables. Alright guys, so we've been working with one table so far, which is the customers table. Now we're going to create a couple more. Okay, so this is a store, so we need to have a products table. So let's go ahead and do that. Okay, so we'll go to our SQL window here, and let's say create table products, and we'll open up some parentheses here, and inside here we want our fields. So we're going to have an ID, which will be an int. It's going to be not null, and we also want it to be auto increment. Okay, we'll also have a name excuse me, a name for the product, which will be a varchar of 255 max. It'll have a price, and price is going to be an int. Alright, and that's what we'll do for fields. Now we want the primary key to be the ID. Alright, so we're going to go ahead and run that. And if we look at our database now, you can see we have a products table. Now let's insert a couple products. So in our SQL window, we'll say insert into products, and we want to define the fields we want to insert into, so name and price. Okay, then we'll say values. So for the first product, we'll just call it product 1, and then for the price, let's say 10. Alright, so if we run that, that should put a product into the table. Alright, so let's go back. Now I'm going to just paste this in. We're just going to add a couple more, product 2, 3, 4, and 5, and we'll click go. And now we have a bunch of products in the products table. Now we're going to create a third table called orders, and that's going to hold the customer ID, and it's going to hold the product ID. Okay, so let's go to our SQL, and we'll say create table orders. Alright, and in here let's say we want an ID. That's going to be auto increment. ID int not null. Okay, then we're going to have the order number, which will be an int. Why does it keeps adding the O? Okay, order number, which is an integer. Then we're going to have the product ID, which will be an int. Okay, then we'll have the customer ID, then let's do the order date. Okay, the order date will be a date time field. All right, and let's say we want the primary key to be ID. All right, now the product ID and the customer ID, these are going to be foreign constraints or foreign keys. And what that means is that this field is going to pertain to the primary key of the products table, which is ID. This will be to the primary key of the customers table, which is ID. All right, so let's define these as foreign keys. So down here, and we're going to do this just like we did the primary key. We're going to say foreign key, and we're going to add in the field name, which will be customer underscore ID. Now, in addition to that, we have to let it know which table and which field this pertains to. So we do that with references. So we're going to say references, and then this is in the customers table, and it's going to be the ID field. All right, so that's how you can define a foreign key. Now I'm going to copy that, and we're going to do the same thing for the product ID. And that's going to be the products table and the ID field. All right, now the last thing we want to do is this order date. I don't want to have to manually put that in. I want it to have a default of the current timestamp. So what we can do is just add on default and then current timestamp. All right, and that'll do it automatically for us. So let's go ahead and run that. All right, and if we check it out, you can see now we have a table called orders. Okay, and it has all those fields we just created. Now you can see the little gray key here. That's telling us that these are foreign key fields. Now foreign keys prevent data corruption, and what I mean by that is if we have if we have a record and it has a product ID foreign key of 3, that pertains to the products table ID of 3. All right, now if we were to delete that product from the products table, and then we have this linking to that product that's not there, that's going to cause a problem. All right, so what this does is it makes it so that we're not allowed to delete something if it has a foreign key somewhere else. Okay, so if we have an order that pertains to that product or that customer, then we don't want to be able to delete that product or customer unless we delete this first, the order first. All right, so hopefully that makes. So let's go ahead and add some orders. All right, so we have some customers, so we'll pick one of these, and then we have some products. So we want to mimic these customers buying a product. So let's go to our SQL window, and let's say insert into orders. Okay, and in here let's say ID. ID. What other fields did we have here? Order number. Then we have customer ID and product ID. And actually I think that's it, because the order date will automatically be put in. All right, so after that we're going to say values. Okay, so actually the ID we don't need to do because that's auto increment. So order number, which I believe is an int, so let's just say 001. And then customer ID, we'll take the first customer, and then we'll take the first product. All right, so let's click go, and then if we go and we visit the orders table, you can see that we have the order number, which it just put 1. Actually, you know what? We don't really need the order number, but we'll just keep it. I did do 001. Since this is an int, it's going to trim off the leading zeros. All right, we'll just leave that for now. So just looking at this table, we don't get that much information from it. All right, we can't see the customer's name, we can't see the product name. It's just some IDs. All right, so this by itself isn't very helpful, but when we use it in a join statement, we can use it to grab information from both tables, the products and the customers, and that's what we'll be doing in the next video. All right, and I just quickly want to add a couple more orders, so I'm going to go in here and paste it in. All right, so we're just adding in the order number, which is just 2, and then we're adding 1 to it, and then the customer ID and the product ID. Okay, so we'll go ahead and run that, and now we have a bunch of orders. Okay, so in the next video, I'll show you how to write join statements. Alright guys, so our online store database now has products, customers, and it has some orders which links the customer to the product that they purchased. So what we want to do now is we want to be able to query orders. But if we were to query just the orders table, this is the data that we'd get, which isn't very helpful. Alright, so we want to be able to get, for instance, the customer's name along with the product title or the product name, not just the ID, because that doesn't tell us anything. Okay, so what we can do is we can write join statements. Okay, joins are used to combine rows from either 2 or more tables based on a common field between them. All right, so in most cases it's going to be between the primary key of one field of one table and the foreign key of another. So there are different types of joins. Okay, so we have inner joins, left joins, right joins, and full joins. Let me just open up a page from w3schools.com, and this gives you a good explanation. All right, so an inner join returns all rows when there's at least one match in both tables. All right, a left join, and that's the most common. A left join returns all rows from the left table and the match rows from the right table. Okay, the right join will return all rows from the right table and the match rows from the left table, so it's the opposite. And then a full join will return all rows when there is a match in one of the tables. All right, and you can read more about this here, and there's some other good articles too if you just do a search for inner join versus right join or left join. All right, so let's go ahead and open up our SQL window, and we're going to write a very simple inner join. So let's say select, and we want to say select customers dot first name, and let's get customers dot last name, and notice that I'm using the actual table name. All right, and I'm doing that because you may have some cases where you have a column name that is a duplicate between tables. So you might have a product name, and then you might have a customer name, and they're both called name. So you can easily make the distinction by using the table name and then dot in whatever the column. All right, so we want the first name and last name from the customers table. We also want the orders dot ID, and let's get orders dot order number. All right, and we're going to say from customers. Okay, so right now it's only from the customers table. Then what we want to do is we want to join in the orders table using an inner join. So we'll say inner join orders. Okay, now what we need to do is tell it which fields to match. So we do that with on, and then we'll say customers.id equals orders.customer ID. So we're matching them by these fields here. All right, so let's go ahead and let's copy it, and then we're going to run it. Okay, so we're getting an error, unknown. Oh, this should be order underscore number. Okay, so now we're getting the first name and last name, and we're getting the ID of the order and the order number. Okay, so we're joining those two tables together. And we could probably do without the ID, just get the order number. All right, so let's go back and let's do a left join, and let's do away with the ID and let's get the order date. So select customers dot first name, last name, and let's do orders dot order number, and orders dot order date. I think that's what it's called. Let me just, yeah, order date. So we want to get this from customers, and then let's do left join orders on customers.id equals orders.customer ID, and then let's do an order by, and we'll do it by the customers.last name. Alright, so let's go ahead and run that. Let's see what's going on here. Oh, I spelled last name. What am I missing here? Order by customers dot last name. Oh, we don't want this comma right here. Okay, so now we're getting our first name and last name, and the order is by last name. We're also getting the order numbers, and we're getting the order date. Now with this left join, you can see that we're getting records that don't even have an order number or order date. It's getting all of the customers, even if they don't have an order. All right, so in this situation, an inner join would be the better of the two to use. Now let's see what happens if we do a right join. Let me just fix this. Okay, so we'll just change this to right join. And now you can see that this actually works out better. Okay, just like the inner join, we're not getting customers that didn't order anything. Now another thing you might want to do is bring in the product info. Okay, you might want the product name. So to do that, we can have multiple joins. So let's go to our SQL, and let's paste that in what I just had. I'm just going to fix this up. All right, so in addition to this stuff, let's add to the end here products.name. Okay, and then we're going to say from, you know what we'll do is we'll say from orders, and then let's go ahead and inner join products. Okay, we want to do an on right here, so on orders dot product underscore ID equals products dot ID. Alright, and then we're going to do another inner join, and this is going to be the customers. So customers on orders dot customer ID equals customers dot ID. Okay, and then we'll do order by, and let's do it by the order number. Alright, so let's see what that looks like. Okay, so now you can see that we're getting the first name, last name, the order number, the order date, and we're also getting the product name. So we're joining in two more tables to our orders table. Alright, now we can also use aliases in these statements. So let's paste what we just did in, and let's do select customers dot first name as, actually, you know what we'll do? We'll use concat as well, just to kind of blend together everything that we've been learning. So we'll say select concat, and then let's grab this. Okay, and we'll cut that out, and let's paste that in here, and then we're going to put just a space right here. So first name, last name as, let's do as name. Okay, and then let's do right here, we'll say concat, and then we'll take the order number and the order date. For some reason I can't right click and cut, so I'm going to just Control C and then delete it and paste that in here, and let's put a space there, and then we're going to say as order. Okay, and then we want product name. Let's just use an alias here. We'll say product name as product. Alright, so let's go ahead and run that. And now you can see we have the name, which has the first name and last name, the order, which has the order number and the date, and then the product, which has the product name. Alright, so that's how we can use aliases and concat along with our join statements. Alright, so that's going to be it for this video. Hopefully you enjoyed it and learned something from it, and I'll see you in the next. Alright guys, so in the last few videos we created our online store database. Alright, we used SQL queries in the SQL window. Now what I want to do is show you how we can put a database project together using PHPMyAdmin, using the graphical user interface. Alright, and obviously this is a little easier than actually writing out SQL statements, but I figured I could still show you how to do it. Alright, so we are in the databases page of PHPMyAdmin. Alright, so we're going to go ahead and create a new database, and let's call it CD collection. Alright, and we're going to create our first table here, and the first table is going to be genres. Alright, so we'll click go, and we want to have an ID, okay, which will be an integer, and we'll give it a length of 11. We also want to set it to auto increment and primary for the index. So this is the primary key. Alright, and then we'll just have a name field, which will be varchar 255. Alright, so genres will have an ID and a name. So let's click save. Okay, so there we go. We have our genres table. Now let's create another table, and let's call this artists. And I don't know how many fields we'll have. We'll just make it 10. Alright, so artists will have an ID, length will be 11, auto increment and primary key. Then let's do name varchar 255. Then let's do a bio, and that'll be a text field. Alright, and I don't know why I did 10 fields, because it's the albums that will have more fields. So ID, name, bio, I think that's okay. So let's go and click save. Okay, so now we have our genres, our artists. Now let's create albums. Okay, for albums we'll just extend that to 8. Click go. Of course we'll have an ID. That's going to be auto increment, primary key. And then let's do artist underscore ID int 11. That's going to be the foreign key for the artists, and then we also want genres. So this will be genre underscore ID. Then let's do the name of the album. And let's do a description, which we'll choose text. And let's see what else. Let's do image. And that's basically going to be a URL. It'll point to an image URL. Okay, let's do release date. And let's choose date for that. And I think that should be good for now. So let's click save. Okay, so now we have 3 tables. Now what I want to do is insert some data, and we can do that easily through phpMyAdmin. So we'll start with genres. Let's click on that and then click insert. And then up here, let's say rock, and we'll say hip hop. Let's add a couple more rows here. And we'll say country and dance. See this ignore, I'm just going to uncheck those. Let's see, what do we got? Rock, hip hop, country, dance, and let's say R&B. Okay, we'll click go. Now if we look at our genres, oh, R&B didn't get added. I didn't uncheck ignore, but that's fine. Now for artists, let's click insert. And I have this page open, this officialcharts.com/charts/album chart, and you can see it just gives us the latest albums, and we're just going to use some of these. Alright, so let's say this Green Day right here, so we'll add in here for the artist Green Day. And for the bio, I'm just going to grab some dummy text for that. Okay, so we'll just grab some of this and we'll paste that in here. Okay, who else do we have here? Barry Gibb. Just paste that in. I'll just change it around a little bit. Alright, and let's add a couple more here. We'll say add 5 more rows. It looks like it copied the description. Alright, that's fine. So let's get another artist. Let's see, Craig David. Okay, then let's see, 21 Pilots. Okay, one more. We'll grab Bruce Springsteen. Alright, so let's make sure that these ignores are unchecked, and then we'll click go, and now we have some artists. Okay, and if we want to edit these, we can, just so they're not all exactly the same. You can double click them here and edit them. Okay, so you can see that using phpMyAdmin is really easy. You don't need to know any SQL code. So now we have artists. Now let's take some of those artists and add some albums. So Green Day has the ID of 1, and as far as the genre, that's going to be rock, so that's the ID of 1. So let's go to albums and insert artist ID 1, genre 1. Okay, so the name of the album is Revolutionary Radio, it looks like. And if I click buy and then Amazon, it'll take us to show us some more info. Alright, so the name is Revolutionary Radio. Okay, description. Let's see if there's a description here. Alright, so we'll just grab this, copy it, and then for the image, what we can do is grab it. Can we grab it from here? Maybe not. Okay, so we'll say save image, or not save image, open image in new tab, and then we want to grab this link here. So we'll copy that and we'll paste that in here. And then release date. Release date, I'm just going to make something up. We'll just say October 5th. Alright, so that's a whole album. Let's add another one. So let's say, who do we have? Craig David. So let's grab that. Following my intuition. Okay, so the ID was, let's see, let me just open this up in another tab. So Craig David is ID 3, and then the genre, I think it's R&B, which we don't have. Let's just say dance, which is ID 4. Okay, so artist ID 3, and then genre ID 4. Okay, the name of the album. Alright, and then description, we'll just grab some of this. Okay, and then release date, we'll say October 2nd. And then the image, let's see, can we get in, if we click buy and then iTunes, let's see, can we grab this, open a new window, open image in new tab, and we'll just grab this URL. Alright. Okay, we'll paste that in, and let's click go, and now we have 2 albums. Okay. Alright, now one thing we haven't done yet is created our foreign keys. So let's go to albums and structure, and then what we need to do is add an index to these 2 fields where we want the primary key. So let's say index. Okay, do you really want to execute alter table, add index? Yes, we do. Okay, we also want to do it to genre ID. Click OK. And then what we want to do is up here, you see how it says relational view. We're going to click on that. And then here, artist ID. We want to, let's see, we're going to choose artists and then ID. And then for genre ID, we'll choose genres and then ID. Okay, and let's see, that's the internal relation. Down here we want to add the constraint. Constraint name, we'll say, we'll just say album key, and then column will be, artist key. And you'll see that the only ones that show up here are ID, artist ID, and genre ID. That's because these are the ones that have an index. Alright, so this will be artist ID and say artists and then ID. Okay, we want to add another column here and we'll say genre ID. Actually, you know what, let's just run this. Oh no, add constraint, that's right. Alright, so this will be genre. There we go. Alright, so let's click save. And now those should be foreign keys. So let's see. Structure, and there we go. So you see the 2 gray keys telling us it's a foreign key. Alright. So now what we'll do is let's do a query here. We're going to use joins so that we can display the album name, the artist name, and the genre name, which are all in different tables. So let's say select, let's say albums.name, artists.name, and genres.name. And we're going to select this from albums. Okay, so we need to get data from the other tables, so let's do inner join. We want to inner join the artist table, and that's going to be on artist.id to album or albums. Let's see, whoops, albums dot artist underscore ID. Okay, and then we'll just copy that, and then this one will be genres. That's going to be on genres.id to albums.genreid. Okay, and then let's just do order by, we'll say albums.release date. Alright, so let's go ahead and run that. And there we go. So we have our album name, the artist name, and the genre name. Okay, now this doesn't look very good with these headings here. They all say name, so we might want to use aliases for that. So let's go back, and I'm just going to paste that in. And let's say select albums.name as album, artist.name as artist, and then genres.name as genre. Okay, so now that looks a little better with the correct headings. Alright, so we have created a CD collection database with 3 tables. And the last thing I want to show you is how to export and import a database through phpMyAdmin. Alright, so make sure you're in the actual database, and then we'll go to export. Okay, and then we can leave everything as is and click go. And then that's going to prompt us to save a file, whatever the database name is, and then .sql. Alright, so I'm going to go ahead and save that to my desktop. Alright, and I'll be including this in your project files. And let's take a look at it real quick. Okay, so I'm going to open it, not with Notepad. We'll just open it with Visual Studio Code. And it has a bunch of info, and these are comments. Okay, this doesn't actually run. And then it can set the SQL mode and the time zone, and then it's going to go and just basically just give us all the queries that we've ran, all right, whether it was manually in the SQL window or through phpMyAdmin. So create tables, albums, we have all the fields. It also adds a couple additional things like the database engine, which is InnoDB, the default character set, things like that. And then this is the insert statement for the albums table. Then we have same thing with the artists, same thing with the genres. Down here is where we added the primary key and the foreign keys. Okay, all the auto increments and so on. All right, now let's say that you have this file and you want to import it into your database. So let's go ahead and create, we'll say testdb, okay, which is now an empty database. And then if we click import and then choose file and go to desktop, and where is it, CD collection SQL, and then click go. Okay, so import has been successfully finished, 22 queries executed. Now if we look at testdb, you'll see that we have all of our tables and we have all of our data. Alright, so very simple. And I think we're going to go ahead and stop here, and hopefully you liked this video and you learned something from it, and I'll see you in the next one. Alright guys, so we're going to move on from MySQL to another relational database system called PostgreSQL, or just Postgres. So Postgres is an open source relational database management system that was developed by a worldwide team of volunteers. So it's not controlled by any corporation or any other private entity. Postgres can be used on all levels, ranging from small single machine applications to larger enterprise level applications with many concurrent users. Okay, like MySQL, it stores data in tables and columns, and it uses the structured query language. So why use Postgres? What are some of the advantages? Well, to start with, Postgres was designed for high volume environments. It uses a multiple row data storage strategy called multi-conversion concurrency control, or MVCC. And this makes Postgres extremely responsive in high volume environments. Okay, the leading proprietary database vendor uses this technology as well for the same reasons. Another plus to Postgres is its reliability and stability. Okay, it's very rare that implementations of Postgres crash without some kind of hardware failure or something like that. Postgres is also very extensible. Customizing or extending PostgreSQL can be done with minimal effort and with no attached costs. Postgres can also be extended with stored procedures. Postgres also has a good number of graphical interface tools available, which I will go through in a minute. It also adheres to the SQL standard very well and in a clean way, and this is something MySQL has struggled with. Okay, this is extremely useful when moving across multiple databases. Another feature, one of the newer features that Postgres has, is support for JSON and NoSQL. Alright, so Postgres can create a bridge between ANSI SQL and JSON. For example, by making the SQL table look like a JSON data set. And this capability allows developers to start with an unstructured data set, and as the project progresses, adjust the balance between the structured and the unstructured data. Alright, so that's something that we'll be getting into later on. So what are some of the disadvantages of Postgres? Okay, there's only a few that I could find. Of course, you have any disadvantages of relational databases in general, but that applies to all of them, not just Postgres. Alright, it does have a bit of a usability and learning curve. I think MySQL is a little easier to wrap your head around, at least in speaking from my own experiences. It's a little slower than MySQL as well, especially for read-heavy operations. The difference isn't really all that significant, but it does exist. And then another disadvantage is its popularity, or rather unpopularity. It is gaining traction, but much more people are using MySQL, especially on a lower level for small and medium-sized applications. Alright, but the documentation is pretty good for Postgres. Now, as far as the requirements, you can run Postgres on a very low-end machine. It's cross-platform, so it can run on Linux, Unix, Solaris, Windows, Apple. CPU, it's recommended to have at least a dual-core 2.0 gigahertz or better, 20 gigabytes plus hard drive space, and 2 gigabytes memory. Alright, it is possible to run it on something less than what's listed here, but these are recommended specifications. Now, Postgres does have some limits, which are listed on its website. Okay, so the database size is unlimited, but the maximum table size is about 32 terabytes, which is humongous. Maximum row size, 1.6 terabytes. Maximum field size, 1 gigabyte. Maximum rows per table is unlimited. Maximum columns per table is between 250 to 1600, depending on the column types. And then the maximum indexes per table is also unlimited. All right, so very, very high limits, to say the least. All right, so Postgres has some really nice tools you can use. Of course, we have the Postgres command line client. Now, we use PHP MyAdmin in the MySQL section, And there's actually a version called PHP PG Admin that is identical to PHP MyAdmin, except it uses Postgres instead of MySQL. All right. There's also a really popular tool called PG Admin 3 that is kind of like PHP MyAdmin, except it's desktop based. It runs on your local system, not in the browser on a server. We also have PSQL, SQL Tabs, and Navicat, none of which I've used, so I can't really say too much about those, but they are available, and there's more as well. So general data types, we have most of the same data types as MySQL. We have characters, varchar, text, integers, all types of integer fields, big int, small int, serial, and big serial. So serial is basically, it creates a sequence to generate values for the column. So it works a lot like auto increment does in MySQL. All right, we will be taking a look at that. Okay, we also have decimals and floats, booleans, which is true or false, and different date fields, so date time, timestamp, and then UUID, which is universally unique identifiers. Okay, so if you need something that is going to be a long unique identifier. In this video, I'm going to show you how to install and set up Postgres on a Windows machine. So we're at postgresql.org/download/windows, and we're going to click on this right here, this download the installer link, and this is the installer by Enterprise DB. All right, there's also a graphical installer by BigSQL. All right, but we're going to choose this one. And on this page here, I am going to click on the latest version for Windows 64-bit, which is what I'm on. All right, so download should start. And let's go ahead and save this. I'm going to save it to my downloads folder. Alright, so it's 137 megabytes, so it could take a minute or two, depending on your connection speed. Alright, so let's go ahead and open that up. Alright, let me just close that up, and we're just going to go through this. So the installation directory, it's going to be in the program files folder, that's fine. And then it's going to have a data directory, which will also be in that folder. And now we want to provide a password for the super user, Postgres. So let's go ahead and add that. Please select the port number. We'll leave the default, which is 5432. Okay, locale will keep default, and click next. Okay, we're going to uncheck the Launch Stack Builder and then click Finish. Alright, so now that Postgres is installed, there's two main methods we can use to access it right now, and that's through the shell in the command line, or through pgadmin, which is a graphical user interface. So let's go ahead and open up the shell. Now the location is going to be C drive, program files, PostgreSQL 9.6 or whatever the version number you have is, and then the bin folder, and you'll see we have psql.exe. Alright, now we want to open this up from a command line, so I'm going to open up a Windows command prompt as administrator, and we'll just navigate to that folder. So program files / PostgreSQL /9.6/bin. And from here, to open up the shell program, we can say psql, and then we need to define the username with -U, and then the user, which is Postgres. Okay, then it'll ask for our password. That's the one you created during the setup, and now we're logged in. Now if we want to see a list of databases, we can do a \L, and you can see we have our default Postgres database, which is owned by the user Postgres, and we're going to ignore the template 0 and template 1. Alright, now to use a database or to connect to a database, you want to do a \c and then the name of the database. So we'll say Postgres. Alright, and you can see right here it says you're now connected to database Postgres as user Postgres. Okay, and if you want to show tables, you can do a / and then dt. Okay, and you can see we have no relations found because there's no tables. Alright, now I'm not going to go any further in this video because I just wanted to show you how to get it set up and to make sure we can run our shell. Alright, in the next video I'm going to show you how we can create a user from the shell program, as well as set up a small database. Hey guys, in this video I'm going to show you how we can log into PSQL in the command line, and we're going to set up a user and set up a database and add a user to that database. So I'm in the bin folder inside of program files, Postgres 9.6, or you may have a different version at whatever time you're watching this. And then we're going to say PSQL -U and then Postgres, which is the username. Okay, we're going to type in our password, and now we're connected. Alright, now to connect to a specific database, you can do \c, or I'm sorry, \c and then the name of the database. But what I want to do first is create a user. Alright, I'm sorry, create a database. Okay, I don't want to connect to that default Postgres database. I don't want to mess with that. So we're going to first of all say create database, and let's just call this we'll call it Acme. Okay, so we get this create database response. Now let's check and see if it actually got added. We'll do a \L, and you can see we have a database called Acme, and the owner is Postgres. Now before we do anything with that, I want to create a user. Now to see the current users that you have, you can say select all from PG_user. Okay, and you can see we have one user with the username of Postgres. Okay, so what I want to do is say create user, and let's call this, we'll call it dev user, and we want it to have a password, so we're going to say with password, and we'll just do 1 through 6. Alright, so let's go ahead and run that, and we get this create role. Now if we do the select all from PG user again, you'll see that we now have a username of dev user. Now dev user right now is not a super user. Okay, so you'll see this uses super is F for false. Okay, and the Postgres is true. I want to make this a super user as well, so what we can do is we can say alter user and then the username, and we'll say with super user. Okay, so you see we get alter role. So now if we do select all from PG user, now dev user has true for super user. Alright, so we can now use that dev user to create other users and so on. Alright, and just to show you, if you wanted to change the password, you could do that with update PG_shadow, and you could say set passwd equals something where username is equal to dev user. Okay, if you wanted to change the password, but I'm not going to do that. Alright, so we now have a user. Now let's add this user to to our database. Alright, so we want to grant, we'll say grant all on database Acme to dev user. Okay, we get grant. So let's take a look at our databases here. We have our Acme. Okay, and over here under access privileges, you'll see we have dev user. Okay, so it's now granted all privileges for that database. Now, if we want to connect as that dev user, then what we can do is we can log out with \Q. All right, and then what we want to do is again do PSQL u and then dev user. Now let's see what happens if I just try to run this. So it'll ask for the password, and then we get this error that says database dev user does not exist. Now when you do this and you're only providing a user, it's going to try to log into a database with the same name. Okay, so since we have a database called Postgres, this worked. So let's go ahead and just add on to this Acme. Okay, and then we'll add the password, and now we're connected. Okay, and we're connected to the Acme database. Alright, so you just want to provide the initial database you want here. If you wanted to switch to a different one, you could always do C and then whatever the database you want to switch to. Okay. So we're going to stop here now that we've created a user and all of that and added it to a database. And in the next video, we'll start to create some tables and insert some data. Alright guys, in this video we're going to be working in the PSQL shell a little bit more. I want to create a table and insert some fields, insert some data. So let's go ahead and log in here. So I'm in the bin directory in Postgres, and we're going to say PSQL u, and let's log in as dev user, and we want the Acme database. Okay, we'll enter the password, and now what we want to do is we want to say create table. Oops. And let's just call this, we'll call it articles. Okay, so create table articles, and inside here let's put in the fields we want. So we'll do an ID. Now this is a little different than MySQL. We're not going to define auto increment. We're just going to define this as a serial field. Alright, and that'll automatically increment. Alright, and then let's do title. Actually, let's make this also the primary key. So we'll just say serial primary key. Alright, and then for title, we'll say varchar 255. And then let's do a body, and for body we'll say text. Alright, so let's run that, and then let's do \DT, and you can see we have our table, our articles table, and it has the owner of dev user because that's what we're logged in as. Now let's try inserting something into this. So let's do insert into articles. Okay, we want to insert, let's see, the title and the body. Okay, so here we'll say values. For the title, we'll just say article 1. And then we'll say this is the body for article 1. Okay, run that. And now let's do select all from articles. And there we go, and you can see it has an ID of 1. So let's go ahead and insert another one. So I'm just going to change this up a little bit. This will be article 2. Okay, we'll run that, and then let's do one more. Okay, and then we'll do select all from articles, and there we go. And you can see the ID is auto increment because it's a serial field. Now I also want to create a categories table, so let's do that. We'll say create table categories, and actually, yeah, we'll just do that. Or no, categories, and then we'll put, let's see, ID, and this will also be a serial and a primary key. Okay, and then we'll have a name, and the name will be varchar 255. Let's go ahead and run that. So that created a table. Let's do /dt, and now we have a categories table. So let's insert something in here. We'll say insert into categories, and we just want to insert a name. Okay, so name values, and we'll say, let's see, business, and then I think we can just put a comma here if I'm not mistaken. So business, technology, and we'll say, I don't know, style. Okay, so let's do select all from categories, and there we go. Alright, now I want the articles to have a category ID field that's going to pertain to these categories. Alright, so to do that, we're going to use alter table. So alter table articles, and we'll say add column category ID, and that will be an int. Alright, so we'll run that, and then let's go ahead and add a category ID to both of our articles. So we'll do an update. Okay, we'll say update articles, and then we'll say set category ID, and we'll set that equal to 1, and we'll say where ID is equal to 1. Okay, and then let's do set category ID. Actually, we'll keep the next one in the same category. So for this, we want to do where the article ID is equal to 2. So now, if we do a select all from articles, you can see that they're both 1 and 2 have the category ID of 1. Alright, so let's do that to article 3, and we'll give that a category ID of 2. Okay, so the third article will have the category ID of 2. Alright. Okay, so now I want to add a foreign key restraint on that category ID field. Alright, so let's do that with alter table, and the table we want to alter is articles, and we want to add a constraint. Okay, so add constraint, and let's just call this cat fk for category foreign key, and then the constraint we want to add is foreign key, and then the field will go in here, so category underscore ID, and then we just want to say references, and then the table which we're going to reference, which is categories, and then the field that's in there that we want to reference, which is the ID. Alright, So now we have a foreign key. Alright, so we've done quite a bit in this video. I wasn't going to get to the foreign key and all that, but I guess the last thing I want to show you here is how to delete, which is really simple. Let's just say delete from articles, we'll say where ID is equal to 3. Okay, and then let's just do a select. And it's gone. Alright, so CRUD functionality, create, read, update, and delete. We also added a foreign key and a primary key constraint. Now in the next video we're going to move away from the command line here, and we're going to start to look at pgadmin, or pgadmin 4 to be more specific. And that's a really nice tool. It has a graphical user interface and has a lot of nice features. So we're going to get into that next. Alright guys, so up to this point we've been working in the command line running SQL commands. So now I want to look at pgadmin. Okay, so if we go to our C drive and wherever you installed Postgres, mine is in program files, PostgreSQL 9.6, and then there's a folder called pgadmin 4. Okay, so inside there we'll go in the bin folder and we're going to run pgadmin4.exe, and that's going to open up pgadmin. Alright, so this is what the interface looks like. I'm just going to maximize it here. Alright, and you'll see that we have this servers here. If I click that, you'll see we have Postgres 9.6. If we click that, it's going to ask for the user Postgres password. So let's say 123456. Okay, and now we're logged in, and you can see if we go to databases, we have our Postgres database, and there's also our Acme database. So everything that we did from within the command line, within the shell, is going to reflect in pgadmin. Okay, it's just a different way to connect to the same system. Okay, not only databases, but if we look in login group roles, we have our dev user. Okay, so we can create users, we can manage our database, and do a whole bunch of things from this interface. In addition to the command line. Alright, and on this dashboard we just have some analytics. We have database sessions, transactions per second, the in and out for tuples, and also our database activity. Now if we look over here under Acme and under schemas and then public, you'll see we have a whole bunch of options here, and tables is one of them. So if we open up tables, you'll see we have our articles and categories tables. If I expand that, and that's hanging for some reason, so let's look at categories and look under columns, and we have our ID and name. Okay, if we want to let's right click on categories, and then we'll say view data, and then view all rows, and you can see there's our rows right there. We have our 3 categories. Now I just want to show you how we can do a couple things in pgadmin. So first thing we'll do is create a user. So if we go to login group roles and we go ahead and right click, say create login group role, and let's say dev user 2, and then in definition we can add a password. We can add an account expiration if we want, a connection limit, -1 just means unlimited. Privileges, this is where we can set the super user, we'll say yes, and can log in, we'll say yes. Can initiate streaming and replication, we'll say yes. So this is a complete super user. Membership, we can add certain roles. We're not going to do that though. Security, labels, SQL. Okay, this is the actual SQL that'll be run. So let's click save. And now you can see we have dev user 2. Alright, we can look at those properties and we can edit that information at any time. So now what we'll do is create a new database. Okay, so let's say create database, and let's call this, we'll call it medic, and we can choose an owner. We'll choose devuser2, which we just created. Okay, definition, you can choose encoding. Let's see, character type, we don't really care about any of that stuff. That's the actual SQL that'll be run. So let's go ahead and click save. And now we have this medic database. And if we go under schemas, public, tables, this is where our tables will go. Alright, so let's go ahead and do create table. And let's create a table called doctors. Okay, the owner of this table will be devuser2. Schema, we'll just leave it public. Okay, columns, this is where we can add all of our columns. So let's click the little plus sign here. And for this one, we'll say ID. And the data type for this, I want to use serial because I want this to be an auto increment field. Okay, over here we can also choose that we want it to be the primary key. Okay, let's add another field. This will be name, and for this we'll choose character. Okay, we're going to choose this right here, character, length, let's say 255. Okay, we'll add another one, and let's say we want just a bio of the doctor. Okay, for that let's choose text. Alright, now we want it to be more than 1 byte, so we want this one with the brackets rather than this one. Okay, and that looks good. Let's go ahead and click save. And now we have a doctor's table. Alright, let's add another one. This is going to be patients. Okay, we'll choose devuser2, and let's create an ID, which will be serial, and that's going to be the primary key. And let's do name, which will be character, length of 255. Okay, this one will be phone, which will also be character. For that we'll say, we'll do 20 for the length. Okay, let's do email. And then here we're going to put a field called doctor ID, and we want to choose integer, and that looks good, so let's save. Alright, now I want to make the doctor ID field a foreign key that points to the doctor's ID field, the doctor's table, and then the ID field. So if we go to, where is it? So tables, patients, constraints, and you'll see the primary key is there. Let's say create foreign key, and we'll call this doc FK definition. We're just going to leave that. Columns, we want to choose doctor ID. References is going to be public.doctors, and then referencing will be ID. Okay, and then click the plus symbol, and let's see, on update we want no action. Delete, I do want to add a restriction to that. Alright, so let's save, and that added a foreign key. Okay, so that's how you can add a constraint. Now let's say we want to add a doctor. We can go to doctors, and let's open up the query tool, and let's say insert into doctor's name and then values, and we'll say Dr. John Doe. Okay, click the little lightning bolt, execute, and we get a success message. And now if we go and view data, view all rows, you'll see we get Dr. John Doe. Okay, yours will probably be the ID of 1. Mine's 2 because I already inserted a row and deleted it, so it continues at 2. Alright, for a bio, we can actually add stuff through here, and we'll just say he is a great doctor, and save. Alright, so if we want to add a patient, we can do that through the query tool, or we can just view the data, and we should be able to add in here. I'll just put myself. Okay, doctor ID, we'll say 2. Alright, so now we have a patient. And if we open up the query tool, we can say select all from patients. Oh, actually, you know what? That didn't add it. Let's go ahead and check that. And let's see, can we do it from here? We should be able to. Oh, you know what? Maybe we can't. Okay, so I clicked save. That did it. So let's go back to the query tool and run that again. Let's see. Now, it only saved the first character, and I think that's because we chose the wrong type as far as name, phone, and email. So let's go to Patients, Properties, and Columns, and apparently we don't want to use that. Let's use, you know, what we'll use is character varying. Let's try that. So save, and we're just going to delete what we just did here. And apparently we can't do it that way. Alright, let's just try to insert from here. So insert into patients. We want the name, email, phone, and doctor ID. Okay, values. And 2. Alright, so let's run that. Okay, so that looks like it was successful. Let's go ahead and view the data. And there we go. Alright, so just you want to choose the character varying for the field type for these. Alright, so that's pgadmin. Personally, I would rather work with SQL queries in the command line than pgadmin, but that's just my preference. I think it's a little too complicated. It's not as easy to work with as, let's say, phpMyAdmin, which there is PHP pgadmin that's available, and that is the version for Postgres. You may want to check that out as well. But in the next video, what we're going to do now is we're going to start to work with PHP and Postgres together. Okay, so I'll show you how to enable the Postgres extension for PHP, and we'll build a simple blog. Alright guys, so we're going to now build a PHP application, using Postgres as our database. Now, before we do anything, there's one really important thing that you need to do. Now, we're using XAMPP for our PHP installation, so I'm going to go into my C drive and XAMPP and then PHP and php.ini. Okay, this is the file you want to edit, whether you're using XAMPP or some other type of, if you're just using a PHP installation on your server, on your web host, whatever, you want to edit this file. Alright, so we're going to open this with, let's say, Visual Studio Code, and we just want to enable the Postgres extension. Okay, so I'm going to do a search for PG, and it's this right here. Okay, this extension equals php underscore pgsql.dll. You want to make sure that you remove the semicolon from in front of it. Okay, I already have, but just make sure you do that. Alright, so that we can use Postgres. Just do that and then save it. Alright, so now what we're going to do is create our project folder. So in XAMPP htdocs, I'm going to create a folder here, and we're going to call this simple blog, and then I'm going to open that from within my Sublime Text editor. Alright, so we're going to create here our index.php file. So let's say new file, save it as index.php. Okay, we'll just do test, and then we should be able to go to http localhost/simpleblog. Alright, so that's, now we can see that that index file is loading. Now we want to connect to Postgres, so we're going to do that in a config file. Let's create excuse me, let's create a folder here called config, and then inside there we'll create a file called db.php. Alright, and then in here we're going to open up our PHP tags, and we're going to create some variables. So let's say db host, that's going to equal localhost. Okay, we'll do db port, set that to 5432, and db name. Okay, now I'm using the Acme database that we already created, alright, which just has a categories table and a post table. Alright, and then the db user is going to be dev user. Okay, db pass. Alright, so if you don't have the Acme database, just go ahead and create that, and I guess I'll show you that real quick just in case you don't have it. So let me open up, let's see, we'll open up pgadmin, which is in program files, Postgres, bin, and let's open that up. Alright, so let's see. Enter my password. And if we look at databases, Acme, and schemas, public, tables, we have a categories table. And if we look at the columns, there's an ID column and a name column. Okay, for articles, if we look at columns, we have an ID, a title, a body, and a category ID. Alright, so those are the fields that we'll be working with. So to connect to Postgres through PHP, we're going to create a connection variable, and we're going to set it to the pg_connect function. Okay, and then in here we'll say host equals, and we're just going to do some concatenation here. We're going to put in our db host variable. Okay, then we'll say port equals and we'll concatenate that, DB port. Then we have our DB name. Okay, then we'll do user. User equals DB user. And then we have our password, which will be DB pass. Alright, so that should connect for us. So let's save that, and then in index.php, we want to include that file. Okay, so PHP will say include config/db.php. Alright, so let's save that and reload. Okay, so nothing's happening, which is a good thing. If we go and let's say we change the username to devuser3 and save and reload, now we get an error saying that the password authentication failed. So we know that everything's okay if we're not getting an error. Alright, so we're connected. Now what I want to do is I want to create a select query so that we can get all of the articles. So we're going to go to index.php. We'll say get articles. Okay, so for this we're going to create a query. Actually, I'm going to call it a_query for articles query. And we're going to set that to select all from articles. And then we want to create a result variable, so a_result. And we're going to set that to pg_query. And that's going to take in our connection variable and also our a query. Alright, and then we're going to say or die. So if something goes wrong, it's going to just kill the connection, and we'll just say cannot execute query, and we can actually put the query right in here. So we'll just say a_query, and let's do /n. Okay, so that should get us the result. Alright, now we want to close the connection down here, so we can do that with pg_close and pass in here the connection. Alright, so what we want to do to get this is we want to loop through it. We're going to use a while loop, so we're going to say php while, and down here we'll say n while. And let's say while row equals, and then we're going to use this pg fetch_assoc, okay, because we want to fetch an associative array with our result. So we'll pass in a_result. Okay, so now we should have access to our posts or to our articles. This actually needs to end right here. All right, and then let's see, we'll create a div. Let's give it a class of blog post. And we'll have an h3. And we want the title to go in here, so we can get that with php echo row. It's an associative array, so we want to put in here title. Whoops. And then we should be able to get the body as well. So we'll copy that, put that in here. Say body. Alright, save that, reload, and there we go. We're pulling the articles from our database. So now that we're connected, we know that we can fetch data. In the next video, we're going to set up our user interface. We're going to actually use Foundation as opposed to Bootstrap, which we've been using throughout the course. And then we're going to also fetch our categories, and we'll Hey guys, in this video we're going to implement Foundation in our UI so that our blog can look decent, and we're also going to work on fetching the categories and displaying those, and we'll move on to create our add post form and all of that. Alright, so we're going to use the CDN for Foundation. So this is cdnjs.com/library/foundation, and I'm just going to grab this CSS file right here, this link. Alright, and then on our index.php, we're going to go right here and start to create our HTML structure. Okay, so that's the head. Inside the head, we'll put a link rel style sheet, and then href, and then just paste that foundation link in there. Alright, and then what we'll do is go to foundation.zurb.com/templates, and I'm going to grab this right here, this blog with sidebar. Okay, if I click on that, it'll open up this template, and we're going to do a Control U, and I'm going to grab from this top bar all the way down to this last div above the script tags. Alright, and then we're going to paste that in our body tags. Okay, and we're going to just edit this a little bit. So let's see, this Yeti agency, I'm going to change that to simple blog. Let's see, in the menu, we just want a home link for now. Okay, whoop, that's going to go to index.php. And let's see, we're going to take everything out of this blog post, or this blog post which ends right here above the next one. Okay, let's take everything out of in between there, and then I want to get rid of the rest of these blog posts. We only want one. So it looks like, let's see, that's the last one, which ends, actually I don't know where it ends. It ends right here, so I'm going to delete up to here. Alright, so it should look like that. And I'm going to grab this while loop that we did, cut that, and put that right here. I'm actually going to replace the blog post div. Okay, because we're looping through them, and then we're going to output all the blog posts. Now for the sidebar, let's get rid of this authors and the UL. Okay, categories right now we'll leave as just the static list. We'll change that in a minute. And then down here, let's get rid of this div row column, which has this pagination that we don't need. So we're going to get rid of that. Alright, so let's go ahead and save and go back to our application and reload, and it should look something like this. Now I do want to have the category name in here, so let's go below the paragraph where the body is, and we're going to put in div class callout, and inside there we'll have a UL with a class of menu and simple, and inside there we'll have an li, and let's put we'll say category. Now in order to get the category name, we have to join it into this select, because from the articles table we just have the category ID. So let's add on to this, and we'll say inner join categories on articles dot category ID equals categories dot ID. Alright, so now we should have access to the name field inside the categories table. So in here we'll say PHP echo, and we should be able to now use row and name. Alright, let's try that. Okay, so now we're getting the category names as well. Now we want to list all the categories on the side here, so let's go create another query. I'm going to copy what we have here for the get articles, and we'll change it to get categories. Select all from categories, and we don't need this join. Okay, and we're going to change this from A query to C query and C result. Change this right here and that. Okay, so now we have this C result that we can work with. So let's go down to where we want to output the categories. Get rid of all but one LI. And in here we're going to say PHP, and we'll do a while. Okay, so we'll say while row is equal to pg fetch assoc, and we want to pass in here c underscore result. Alright, and then we want the category name right here, so php echo row name, and then we want the link to go to category.php, and we want to add a parameter of id equals, and then put in the ID of the category. So we'll copy that and paste that in and change this to ID. Alright, and then we'll also add that link up here to the category name. So let's copy that whole A tag and put that right here, and we'll end it right here. Alright, so let's save it, reload, and now we get all our categories on the side here, and if we click it, it takes us to category PHP, ID equals, and whatever the ID. Alright, which is what we want. So this page is now all set. In the next video we're going to create a new page so that we can add a new post or a new article, and we'll go from there. Alright guys, so we can now list our articles in our blog application. Now what we want to do is we want a way to add articles through the application. So I'm going to go to the nav bar on the index page, and I realize that this HTML isn't formatted very well. Just that's really not the focus on this, but I should make this look a little better. Okay, let's see, that ends there. That ends there. Okay. Alright, so what we'll do is add a link here, and it's going to go to new.php, and for the text we'll just say new post. Alright, so let's create that file. We'll say new file, save as new.php. Okay, let's copy everything we have here, paste it in, and we're going to get rid of this stuff. Okay, and let's see, this will all stay the same. What we want to take out is this whole while loop right here, and we'll leave the categories. Actually, you know what, I'm just going to undo what I did. We want to keep this because we do want to get the categories, but we'll get rid of the get articles. Alright, and then we'll get rid of the while loop. Let's put in an H2, and we'll just say new post. Okay, save that. Now if we click new post, it takes us to that page. Alright. So we're going to add a form here, and it's going to have a method of post, and then an action And I want it to submit to itself, so we're going to use a special super global. I'm going to use the server super global. Actually, let's do echo right here. So money sign underscore server, and then we want PHP underscore self. Alright, so that'll submit to this the same file. Okay, and then inside the form, let's create a class of row, and then we'll do div class medium 12 columns, and then inside here let's say label, we'll say title, and then our input, which will have a type of text. Okay, let's give it a name of title and a placeholder of title. Okay, just space this out a little bit. Okay, let's take a look at that. So there's our first field. Let's copy this row div and everything in it. Paste that in, and this will be the body. Okay, but this is going to be a text area. So text area, name, title, placeholder, title. That needs a closing tag as well. Let's see. Actually, I want to change the name to body. Okay, so that'll be the body. Now we also want a drop down of the categories. So let's go ahead and copy the row again. And let's see, we're going to change this to category. And then this is going to be a select. So select name is going to be category ID. Okay, it's not going to have a placeholder. And then it needs a closing select. Okay, let's put an option with the value of 0. And then this will just say select. Alright, so now what we want to do is we want to loop through the categories and then output an option for each one. Alright, so let's copy what we have down here where we're going through the categories. Paste that in. And let me just make this wider. Okay, so we don't need excuse me, we don't need the list items. Let's get rid of that. And then inside the while, we'll grab this option. Okay, and then for the text, we'll say PHP echo row. That's going to be the category name. Okay, copy that. And then for the value, it's going to be the ID. Alright, so let's save it and reload. And now we have a drop down with the categories. Alright, now finally we need a submit button. So that's going to go under the row div right here. And let's say input type equals submit. And let's give it a name of submit, a value of submit, and give it a class of button. Okay, so we have our form. Now we're submitting to this same page, so we're going to go up to the top here, up in our PHP, and let's go right here, and we're going to say if is set, and we're going to check for post submit. Okay, and then we'll just say echo test. Okay, so if we just go to the page, we don't see the tests here. If we submit, it shows up. Alright, so we know that that's working. Alright, so what we want to do is, first of all, let's get the title from the form value. So we can get that with post title. Okay, we want to do the same thing with the body and the category ID. So this will be body category ID. Okay, so that'll get the values for us. And then let's do query, and we'll set that to insert into articles. Okay, title, body, category ID, and then we want the values. Okay, so values, these are going to be in quotes, title, body, and category ID. Then directly under that, we want to say result equals PG query. And here we want to pass in the connection variable and the query. Alright, and then we'll just we'll do a redirect. So header location will be index.php. Alright, so let's save that and click on new post, and let's say post 4, and let's choose a category of style and submit, and there we go, post 4, and it has a category of style. So we can now submit posts. Now this isn't the best way to do it. This is actually pretty insecure because we can insert just anything. What we want to do is use more of a prepared statement. So I'm going to just comment out query and result, and we're going to use something called PG query params, which is a safer way to do this. Okay, so we'll say PG underscore query underscore params, and then we want to grab this insert statement and paste that in here, and then it's going to have a second parameter which will be an array, and then what we want to do is replace these three variables with 1, 2, and 3. Alright, and then in this array is what we want to replace them with. So title, body, and category ID. Alright, and that'll do the same thing, but it's more secure. Okay, it's expecting these 3 values. So let's go back and go to new post. We'll say post 5. Say technology, submit, and there it is, post 5. Alright. And it's weird that it's out of order. I think that's because just because we changed the way that we add them. Alright, so what we want to do next is we want to be able to filter these by category. So for instance, if I click business, we want to just see the post from the business category. Alright, so that's what we're going to get into next. Alright guys, so we're just about there. I just want to be able to filter these posts by category. So we're going to create another file in our root here called category.php. Okay, and we're just going to copy everything that's in index. Okay, so copy that, and we'll paste that in. Now, the body is basically going to stay the same, but we want to change up the query a little bit. We want to just implement a where clause and grab the ID from the URL and implement that in the query. So to do that, we're going to create a variable called ID. We're going to set it to get ID, and then we just want to use that in our query. So right here, select all from articles, inner join, and at the very end we're going to add where ID equals money sign ID. Alright, let's make this look a little neater. Okay, I think that looks a little neater. Okay, and we'll do the same thing on the index page. Alright, so now if we reload, and we're getting column reference ID is ambiguous. Now, this is happening because both the articles and the categories, they both have an ID field. So we don't want to just say where ID equals ID. We want to say where article, no, what do we want to say? Articles dot category underscore ID. Alright, and now if I click on business, we only see the business, technology, and style. Alright, so that's going to be it for this project, guys. Hopefully you enjoyed it, and I would suggest that you look more into this and maybe add in some update functionality. There is a lot you could do with it, and I would suggest continuing to work with Postgres overall. Alright, so thanks for watching, and I'll see you in the next video. Alright, so this section is going to be dedicated to MongoDB, which is a NoSQL database. But before we jump into Mongo, I just want to touch on NoSQL and explain what that is. So a NoSQL database is a database that provides a different mechanism for storage than traditional tabular relational databases, such as MySQL and Postgres, which we've already gone over in this course. So one common misconception is that NoSQL, it doesn't actually mean no SQL. It means not only SQL. Alright, a better description would be non-relational. It's an alternative to SQL, but in many cases, it can in fact apply SQL-like concepts. Alright, so motivation for this approach includes simplified design, horizontal scaling, which I'll get to in a minute, and finite control of the data structures. So NoSQL has been increasingly popular with big data and real-time web applications. Big data is something that relational databases have struggled with all the data that's needed for social networks and search engines. Companies like Facebook and Google, they've moved to or created their own NoSQL solutions. So what are the advantages of NoSQL over relational databases? As I said, big data is a huge reason. They can typically hold more as they're easier to scale. Another advantage is that we don't have to define an explicit schema or table structure like we do with relational databases. You saw in the MySQL and Postgres sections that we had to really plan out the schema before we even did anything. We had to know the exact tables, the columns, the data for every record, the data type. With NoSQL, we can just start programming and the structure will adapt around our programming. Alright, so we can create collections and fields on the fly. NoSQL is also much easier to scale. It uses a horizontal scaling method, and I'll go over that, go over what that means in a minute. The final two advantages really go together. It's less expensive and needs less management. Alright, not having to pay administrators to manage the database directly will ultimately save you money. It's also less expensive because we can use much lower end hardware as we can scale out. Alright, so with that said, there's a couple downfalls with NoSQL. Its maturity, for instance. Relational databases have been around for decades and they really haven't changed much, so that can be quite reassuring. A lot of NoSQL systems are still in pre-production versions with key features that are yet to be implemented. Alright, and this may be exciting for developers, but there can be a general sense of hesitation on the enterprise level. And maturity directly ties into the next, which is support and community. Alright, there just aren't as many developers and administrators with hands-on NoSQL experience, so help can be a little harder to come by than with relational databases. All right, so NoSQL has been really focused on scaling to the demands of new applications. So there's few facilities for ad hoc query and analysis. A lot of the common tools in the industry don't provide connectivity to NoSQL, at least at this time. All right, so lack of analytics and business intelligence can also be a small disadvantage. All right, so I briefly mentioned that NoSQL commonly uses horizontal scaling, and this is also known as scaling out or scaling in, and this pertains to adding more nodes to a system to scale up. All right, so if we add a new computer to a distributed system, if we scale from one web server to 3, those are examples of scaling out horizontally. We can have hundreds of small computers configured in a cluster, and this can be really powerful. Not to mention, we can use low-end machines and combine them for high performance. Now, when dealing with relational databases, we scale vertically or up and down, and this means that we're adding resources to a single node in a system, and typically high-end and expensive resources like CPUs, memory, and disk drives. All right, this method of scaling does give you an advantage if you plan on using virtualization, but typically horizontal scaling is a better and much less expensive and more expandable method. All right, so let's take a quick look at the different types of NoSQL databases because they're not all the same. In fact, some look nothing like others. So there are more types, but the main 4 are column databases like Cassandra, HBase, Vertica, document databases which is what MongoDB is, CouchDB, Rethink, key value stores like Couchbase, Dynamo, Memcached, Redis, which we'll take a look at some of these later on in the course, and then graph databases like Neo4j and MarkLogic. All right, so a column database uses columns which are distributed data stores. There are NoSQL objects of the lowest level in a key space. All right, so they're tuples, which are key value pairs, and they consist of 3 elements: a unique name, a value, and a timestamp. All right, and you can see a small example down here. We have a date column, a price column, and a size column. All right, so it's similar to a table or a relational database table, just much simpler. A key value store is a data storage paradigm designed for storing, retrieving, and managing associative arrays, a data structure more commonly known as a directory or a hash. All right, so down here you can see we have a key and we have a value, and that's basically what it is, a key and a value. And a value can have multiple sub-values. You'll see here separated by a comma. So key value store. Graph database is a database that uses graph structures for semantic queries with nodes, edges, and properties to represent and store data. A key concept of the system is the graph, which directly relates to data items in the store. All right, so down here you can see we have these different nodes, and we have edges which can connect the nodes together, forming relationships. And finally, we have a document database, which is what MongoDB is, designed for storing, retrieving, and managing document-oriented information, also known as semi-structured data, and data stored in JSON-like documents. All right, MongoDB actually uses something called BSON, which is a binary representation of JSON. All right, so down here you can see we have a document which is wrapped in curly braces, and this one has an ID, a name, a brewer, and units, okay, which can be different types of data, which we'll talk about in the next slide. All right, so now that you have an idea about what NoSQL is, let's focus on the individual NoSQL database, MongoDB. As we've established, MongoDB is a document database. It is open source and completely free. It uses a combination of the GNU AGPL and Apache license, and MongoDB was built with scalability and the developer in mind, so simple but powerful. And instead of using tables, it uses a collection or collections of JSON-like documents. All right, so MongoDB has all the benefits of NoSQL. It's schemaless, so we don't have to define everything beforehand, including collections, fields, and data types. We can just program and it'll work. Okay, one collection holds different documents, and those documents can have unlimited fields of any type. All right, so back when we were working with MySQL, we had to define every single field. We had to define it as an integer or a varchar. We had to add a primary key, auto increment, all this stuff. We don't have to do that with NoSQL, so it's much, much more flexible. All right, a structure of a single object is very clear, which I'll show you in a second. We don't have to do any complex joins using multiple tables or collections. There's a much deeper ability to query efficiently, and it's also easy to scale out. Okay, it uses horizontal scaling like most NoSQL systems. Documents and collections. So MongoDB is built on an architecture of collections and documents. Documents comprise sets of key value pairs and the basic unit of data in MongoDB. So a document can be thought of as a row of data in a relational database, and then collections can kind of be thought of as tables in a relational database. All right, so these documents, they're JSON-like syntax, but they're actually BSON, okay, which is a binary representation of JSON representing simple data structures, associative arrays, and various data types of specific interest to MongoDB. All right, and this here is a list of all the different data types that these documents can hold. So we have strings, integers, 32 or 64-bit, doubles, dates, byte arrays, booleans, which is true or false, null, another object, an array, some JavaScript code, MD5 binary data, and a regular expression. Okay, so we can store, excuse me, any of these data types in our documents. So here's a very, very simple document example. So these documents will be wrapped in curly braces, and if you know JavaScript JSON syntax, this is pretty much exact. We have key value pairs in here, so we have a name, and that's a string of Sue. Notice that strings will have quotes around them. This is not. This is a number, and it doesn't have quotes. Okay, so we have a name, an age, status, which is a string with the letter A, and then groups, which is an array of strings. Okay, so we can store arrays or even other objects inside of an object, inside of a document. So let's do a little comparison. So this here is from a relational database, and this is for a blog system. We have 4 tables. We have a blog post table, blog comments, blog tags, and author. All right, and you can see we have primary keys, ID, we have foreign keys. All right, so author ID is a foreign key of from the authors table. We have blog ID, which is a foreign key from the blog post table, and it can get quite complicated, especially if we're dealing with dozens and dozens of tables. Now, if we look at a document, you can see that everything is in the same document. We don't have multiple documents where we're adding relationships, so we have to do joins and all that junk. It makes things much, much simpler. So we have an ID, we have an author, which is another object or another document, which has a name and an email. Post, which is a string. We have a date. Location, which is an array of coordinates. Rating, which is a number. Comments is an array of objects. Okay, so we can just stick the comments right in there instead of creating a whole nother table. And then we have tags, which is an array, okay, instead of adding a whole tags table. So you can see the simplicity of this, and it just makes things work much easier. All right, now that's not to say that relational databases are not better in some projects. If you have data that's really closely related and you have a lot of read operations and there's some other criteria where relational databases would in fact be a better choice than NoSQL. All right, but if you just have a whole bunch of data that you just need to store and that there's not too much going on with interconnected relationships, then NoSQL is probably the way to go. All right, guys, so we're going to go ahead and download MongoDB in Windows and install it. So I'm at mongodb.com, and I'm going to click this download button up in the top right. And for some reason, when we click on that link, it brings us to the download center, and it says filter enterprise, and we don't want that. I'm just going to get rid of that filter right there because we don't want the enterprise version. We want this community server. All right, so let's see. I'm going to choose Windows Server 64-bit. Okay, you know, obviously you can install in Linux and Mac as well. So we're going to download the MSI installer. Save that. Okay, it's 101 megabytes. Okay, so that's downloaded. Let's open it up. Okay, we're going to go through the installer. Just click Next, accept the terms. Now I'm going to click Custom right here because I want to change the location. All right, by default it's going to go in Program Files, MongoDB Server 3.2, and that's too long. So what I want to do is click Browse, and in my C drive I'm going to create a new folder called MongoDB. Alright, and that's where I want to install it. Click OK, and now you can see it's going to go into C drive MongoDB. So I'm going to click Next and install. Alright, so we're going to click Finish. Now, there's a couple extra steps we need to take. We want to open up the location where we installed it. In my case, it's going to be right in the C drive. And you can see I have a, MongoDB folder, and in here we're going to create a folder called data. Alright, and then inside the data folder we're going to create another folder called DB. Alright, and this is where our data will be stored on the file system. I'm also going to create a folder called log. Now I'm going to open up a command line as an administrator. Alright, so I'm going to navigate to that MongoDB bin folder there. So I want to go cd mongodb/bin. Alright, and then from here we want to say mongod, and then we're going to add a couple flags here. We want to do -- directory per db. Okay, then we want to do -- db path, and this is the path to the data db folder we just created. So it's going to be c/mongodb/data/db. Alright, then we're going to say -- log path, and then add that. So that's going to be C drive MongoDB/log, and then it's going to be a file called mongodb.log. Alright, then we want to add a couple more flags. We want to do log append, we want to do -- rest, and then -- install, which is going to allow us to install it as a service because we want it to run as a service in the background. Alright, so let me just double check this. Okay, so that looks good. We're going to go ahead and run that. Alright, and now we want to start the service with net start MongoDB. Alright, and you can see that the service has started successfully. So now that that's up and running, let's go ahead and type in Mongo. Alright, so now we're actually in the Mongo shell. Okay, if we want to say show DBs, it'll give us a list of databases, and by default we just have this local. Alright, now I'm not going to get into writing queries right now. I just wanted to show you how to install it and get it set up, run it as a service, and then in the next video we'll start to work in the shell. Hey guys, in this video I'm going to start to show you how to create a database in MongoDB through the shell, and also how to create some queries. Alright, so I have my command line open here, and I'm going to just navigate to my MongoDB directory, which is right in the C drive, and then we want to go into the bin folder. Oops, not bin, not bon, but bin, and then we're going to run Mongo. Okay, and that's going to open up the shell. Now from here we can show our databases by saying show DBs. Okay, all we have is this local database, which we're going to ignore, and we want to create a new one. So to create a new one and to go into it, we can just say use, and let's say project manage, or project management. Alright, because we're going to be building a database for a project management system. Alright, and you can see we switch to database project management. Now what we want to do is create a collection. Okay, a collection can sort of be thought of as a table in a relational database. It's a collection of documents. So to create a collection, we're going to say db.create collection, and we're going to call this collection projects. Okay, so we get this OK1. That means that everything went okay. Now if you ever want to check the database that you're in, you could just simply say db, and you can see we're in project management. If you want to show the collections, we can do that as well with show collections, and there's our projects collection. So what I want to do is insert a project. Now I'm going to type out my queries, my documents in the editor here so you can see them better, because it's not as readable in the command line. So let's start off with what an object should look like. So it's going to be surrounded in curly braces. And let's say for our project we want, let's do a name. Okay, so our project name, let's say simple website. Actually, we'll say company website. Okay, so we simply have a key value pair. This is a key, and then this is a value, which is a string. Alright, so in addition to the name of the project, we'll say category web design. Okay, let's do due date. Alright, now for this we could just put a string if we wanted to, but we could also use a date format. Alright, so to do that, we'll say new date. Okay, we can actually use the date function, and in here we'll say 2016, and let's do we'll say 12/12. Alright, so that'll get saved as an ISO date. Alright, now let's say technologies, and for this we'll use an array. So we'll say HTML, CSS, and JavaScript. Okay, so simple array. We could also do, let's say, developers. So for developers, let's do an array of objects. Okay, so we could say name, and we might want to do something like role. So we'll say role, we'll say leader, or head developer, or head programmer sounds better. Okay, then we might want another one. Say John Doe. And role, let's say designer. Okay, so we can have an array of objects. We could also do just an object. So let's say client, which will be an object, or a document. We could call it a document. Say name, say Stephen Smith, and let's say email, and phone. All right, and then let's add one more, and this will be the, let's say, cost. All right, and we'll make this an integer. We'll say 2,000. All right, so that is a document, okay, in all senses. So what we want to do is, let's actually wrap this in db.projects.insert. Okay, and then we're just going to wrap that. And then what I'll do is copy this, and we'll go over here and paste that in, and then run it, and we get this right result, inserted 1. All right, now to check on that, we can say db.projects.find. And there it is. Now that looks a little clumped together and it's hard to read. We can actually add on to that find. We can say .pretty, and that'll make it look a little better. Alright, so now we can clearly see the fields. Now notice that there's an underscore ID field, and we didn't create that over here. MongoDB automatically creates an ID field and assigns it an object ID. Alright, so we have this long string of numbers, and this is what we can use to uniquely identify the documents that we need. All right, and then we have our name, category, the due date. You can see is formatted as an ISO date. We have our technologies array, our developers array of objects, and our client object, and then the cost. All right, now I'm going to paste this in because I want to add a couple more, but it's quite long, so I'm going to paste this in, and let's just look at it. We have db projects insert, and notice that we have the brackets now because this is an array of objects we're inserting, okay, because we're inserting more than one. So this is a blog application, category web programming, we have a date, we have some technologies, I added PHP and MySQL, developers, client, cost. Okay, this one's an e-commerce store that uses Ruby on Rails. And then this one is a recipe mobile app that uses Objective-C and Java. Alright, so let's go ahead and paste that in here. Okay, and now you can see we get this n inserted 3. Alright, so if we go and we do find, you can see that now we have all those projects listed in that collection. Alright, so that's how we can insert data. In the next video, we're going to talk about how we can query, select, and find this data in different ways. Alright, in the last video, we went ahead and inserted some data into our database, into the projects collection. Now I'm going to show you different ways that we can get data from it. Alright, so I'm going to save this document in the project files so you guys can have it as reference. First thing we'll do is let's find all projects, and we've already done this, but I do want to just include it in here. So we can say db.projects.find. Alright, so if we go ahead and run that, it just gives us all the projects, and it's not very nice looking, it's not very readable, so we can use the pretty function to fix that up. Alright, and any functions that we can use in MongoDB, we can just chain along like this, which is nice. Okay, so you can see that looks a lot better. Now, what if we want to match a certain condition? Alright, so this is kind of like a where clause in SQL. So let's say we want to find the record that has the name company website. So we could say db.projects.find, and in the first parameter here we'll open some curly braces and we'll say name company website. Okay, so if we go ahead and run that, I'm just going to make this a little bigger. Okay, so if we run that, we get nothing. That's because I spelled this wrong. Okay, so that gives us that one item, that company website project. Alright, so we can also use this to find array values. So let's say we want to find projects that are using the Ruby on Rails technology. We don't need some special query. We can just say technologies, and we'll say Ruby on Rails. Okay, so we'll copy that, and you can see this gets pulled up because it has Ruby on Rails in the technologies array. So it'll match it whether it's just a single string or it's something that's inside of the array. Alright, so what about an object? Alright, let's say we want to find this client right here, Harry White. So what we can do, let's say db.projects.find, and then in here I'm just going to put this on a new line. We'll say client Harry White, and let's do email, and phone. Okay, let's go ahead and run that. And there he is. Alright, so, and it just gives us the record that has Harry White as a client. Now, if we were to paste that in, if we were to change something here, such as the phone number, and we try to run that, you'll see it gives us nothing back. Alright, because it has to match it exactly. It has to have all these fields and they have to be exact. Alright, now if we want to, let's say, just match the name Harry White and not care about the email and phone matching, we can do that pretty easily. So we'll say match property in object. Alright, so what we'll do is we'll just say, we actually need to put quotes here, and we're going to say client dot name. So client dot whatever the property you want. Alright, and let's choose someone else. Let's see, we'll get Stephen Smith. Okay, run that, and let's see, missing parentheses. Oh, we need to put the curly braces. Alright, so that gives us Stephen Smith. Another thing we can do is we can use regular expressions. Okay, so if we do db.projects.find, and let's say we want to find where name, and I'm going to use a regular expression. I'm going to use this slash, and then the caret symbol, and then capital R, and another slash. Alright, I'm not going to go into regular expressions and formatting them, but what this one means is that it's going to look for something that begins with the letter R. Okay, this caret symbol represents begins with. Alright, so if we were to run that, you'll see that it returns this with the name recipe mobile app. Alright, if we were to change that R to, let's say, a C, then we're going to get the company website. And if you don't know regular expressions, you feel free to look some up and throw them in there and see if you get any matches. Now, in addition to find, we also have find one, which works in the same way, except it only finds one instead of finding a bunch of projects. Alright, so if we say db.projects.find1, we can run this without any parameters or anything, and it'll just give us the first one it finds, which is company website. Alright, of course you might not want the first one, you might want to specify something, so we can do that as well. Let's say name, blog, application. Okay, so if we run that, it gives us the blog application. Now, up to this point, we have been returning everything from a project. Now, there may be cases where we actually want to limit what is returned, so we can do that as well. So let's say specify what to return. Alright, so if we say db.projects.find, and in here let's pass in an empty set of curly braces because I want to get everything, and then here we'll open another set of curly braces, and let's say we want to get the name, so we're going to say name1, and it's maybe the client, and we'll do .pretty. Now the one means that we want to include this, alright, and I'll show you how to exclude them as well in a minute. So let's run this. Alright, so now you can see that it's getting everything, and it's just getting the name, the client, and it also gets the ID. Okay, it's going to get the ID even if we don't specify it. Now if we want to exclude something, let's say exclude, and let's copy that, and let's say client 0, and let's not do the developer or developers. Okay, so to exclude them, we can just put a 0. So let's go ahead and run that, and now it gets us everything except for the developers and the clients. Alright, so we're going to go ahead and stop here. So this shows you a couple different ways to fetch data. We're going to move on and take a look at some operators as well, so we can even extend the capabilities of our searches or our finds. Alright, in this video we're going to continue to use the find query, and we're going to be looking at cursor methods. Alright, so the first thing we're going to look at is sort. So we can sort our results. Let's go ahead and put a comment here, and we'll say db.projects.sort. Alright, I'm sorry, projects.find.sort. And then in here we need to pass in what we want to sort by. So let's put in some curly braces, and we'll say name1. Okay, I want to sort by name. Alright, now I want to limit what we get back just so we can see them easier. So let's pass in an empty set of curly braces because we want everything, and then let's specify that we want the name, and let's get the client. Alright, and then we'll add the .pretty function at the end here. Alright, let's copy that and paste that in here and run it. And now if we look at the names here, you can see blog application, company website. It's now sorted in the order of the name. Now this is ascending. We can also do descending if we go and we change the 1 to a -1. Run that, and now you can see it starts with recipe mobile app and it ends with blog application, so it's now reversed. It's descending. Alright. Next one we're going to look at is limit. So limit does just that. It limits the amounts of documents that we get back. So let's say limit projects.find, and we're going to say .limit, and let's pass in here 3. All right, and let's also limit what we get to the name and the client. Okay, we'll copy that. Actually, let's add the .pretty. Okay, so now it's just getting 3. It's getting the 3 latest documents. Okay, now we also have skip. And what skip does is just that. It'll skip from the beginning. So let's say we'll copy that, and let's do excuse me. We'll do .skip, and let's say 2. Okay, we'll paste that in. And now what it did is it just skipped the first 2. So the first 2 were what were they? Company website and blog application, and you can see that those 2 aren't showing now. Okay, so we skipped those 2. We also have count, which I'm sure you can guess what that does. You could say db.projects.find.count. Run that, and we get 4. Now when we run find, what it does is it returns a cursor. Alright, so a cursor basically needs to be iterated through, and when we just run this find query like this, it does the iteration for us. Alright, but we can actually assign a cursor to a variable. So if we go, I'll type it in here first. So let's say cursor var, and we're going to say var, we'll call it my cursor, and we'll set it to db.projects.find. Alright, so if I grab that, we can actually paste that in there and run it. Okay, we don't get any return value because we're just setting it to that variable. Alright, but now we can run stuff, we can run functions on this. So for instance, we can say my cursor.count. Okay, and it gives us 4. Now if we want to iterate that through this, there's a few things we can do. We can run next. So if we say over here, let's do my cursor, we'll say my cursor.next. Alright, and then that's going to give us the next value. So let's run that. Okay, so that gives us company website, and it's just giving us 1, as you can see. Now if I run it again, it's going to give us blog application, which is the next one. Alright, we can continue to run that, and it'll iterate through. Now when we get to the end here, we'll get an error that says has next false. Alright, so in addition to the next function, we have this this Boolean value has next, which will tell us if it actually has a next value or a next document. Alright, so if we want to test for that before we actually run next, we can do that as well. So we can use a shorthand syntax and say my cursor dot has next, and then we'll put a question mark, and if it does have a next, then we'll run my cursor dot next. If it doesn't, okay, we'll put a colon, and then if it doesn't, then we'll just return null. Alright, so again, let's put that in a variable. Okay, so now it's stored in that variable, and now we'll grab this, paste that in. Okay, we get the first one, Keep going through, and then finally you'll see when we don't have it anymore, it gives us null. Okay, so we can check to see if there's a next value. Now if we want to just loop through these and output them, we can use for each as well. So if we say my cursor dot for each, and in here let's say we'll say print JSON. Okay, so first let's put it in a variable, and then we'll grab that and run it. Oh, missing parentheses. Let's see. Cursor dot for each. Oh, I think we just, yeah, there shouldn't be a space there. Alright, so it basically just did the same thing as if we were to just run find. Okay, so we can run for each to loop through those. So that's how we work with cursors. In the next video, we're going to take a look at some operators and also aggregation. Alright, in this video, we're going to take a look at some operators we can use with find as well as aggregation. So the first operator we're going to look at is $EQ, which is the equal to operator. So we can say db.projects.find, and in here we'll pass in our curly braces and we'll say cost. Actually, no, we'll say, yeah, cost. And then money sign EQ. Let's say 2000. So what we're saying is we want to find all of the projects that have the cost that's equal to 2000. Alright, so let's copy that. And let's see, what am I missing here? Oh, we need curly braces right here as well. Alright, so that gives us a company website, which has a cost of 2000. Alright, now in addition to that, we have one called NE, which is not equal to. Alright, so NE, and then let's just change that to NE, and then I just want to add the pretty function to the end of it. Run that, and now you see that we're going to get everything except records that have, or documents that have the cost of 2000. Alright, so it gives us everything else. We also have one called exists, and it does just that. It checks to see if something exists. So let's go ahead and paste that in, and we'll change this to exists, and we want to set this to true. Okay, so this is going to give us everything that has a cost. Alright, so let's paste that in, and it should give us everything. Okay, it gives us everything because everything has a cost. If we were to say false, you'll see it gives us nothing. Alright, so that's exists. Next ones we're going to look at is greater than and less than. So let's copy that, and we'll say cost GT, and let's say greater than 10,000. Paste that in, and the only one it gives us is this mobile programming, which is a cost of 12,000. Now if we want to actually count 10,000, because we do have one that has a cost of 10,000, we could do GTE, which is greater than or equal to. So if we go and we run that, now we get the one that's 12,000 and 10,000. Alright, and then of course we also have LT and LTE, which is less than and less than or equal to. Alright, I'm not going to run them because you know what they do. Okay, next one we have is in, and that basically allows us to find documents where the value of a field equals any value in a specified array. So let's do db.projects.find. Alright, and in here we'll pass in curly braces, and I'm going to put this on a new line, and let's say category and then we'll put in our in operator, and then an array, and we'll say web design and web programming. Okay, let's grab that. And then it gives us everything that has a category of web design or web programming. Alright, you'll see the mobile programming isn't in there. So that's in. We also have and or. So for this, let's say projects.find, and let's do or. I'm going to put in some brackets here, and we'll say cost. Let's say if cost is equal to 2,000, and then put a comma here, and then we'll say cost is GT greater than 10,000. Alright, so this is going to return something that is equal to 2,000 or greater than 10,000. Let's see, what did I miss? Oh, this should have a curly brace. Okay, so there we go. We have the one with 2,000 cost and then 12,000. At the same time, we can also do and. Okay, or has to be one of these, and has to be both. So let's go ahead and say and what we'll do is we'll say category is equal to mobile programming, and cost is greater than 10,000. Whoops. Okay, we'll run that, and we get the mobile programming one because it is in fact mobile programming, and it is above 10,000. So that's and or. Now we can also do db.projects.aggregate, and we have a couple other things we can do. Alright, so db.projects.aggregate, and you saw that we used the cursor method limit in the last video. Well, we can also use the limit operator, so we can say limit to. Okay, so if we run that, you'll see that it's going to get us two documents. We can also use skip, which will skip the first whatever we put. So let's say skip to. Okay, paste that in, and it skips the first two. You can see we're only getting e-commerce, store, and recipe mobile app. Okay, we can also sort with this. So let's do sort, and we're going to set that to name 1. Okay, so that'll sort by name. Let's add the dot pretty. Okay, so now it's being sorted by name. You can see we have the blog application, company website, e-commerce, and recipe mobile app. Alright, and then the last one I'm going to show you is match. Whoops. Aggregate, and in here we want to pass in some brackets, and then I'm going to say match. Let's say we want to match where name is company website. Okay, paste that in, and it gives us company website. So you'll see that some of these do the same exact thing as other stuff we've done. It's just a different way of doing it. Alright, and there's actually one more thing I want to show you, and that is concat. Okay, so we can actually put multiple fields together and concatenate them. So if we say db.concat, projects.aggregate, and in here we'll put in our brackets. Let's go like that, and we'll say project, and then we can make up a name here. Let's say project description, another set of curly braces, and then we want to do concat, and then a set of brackets, and in here we're going to put in some quotes and say name. Okay, then we'll do space. Let's do a hyphen in the middle here, and then the category. Okay, so we're making this project description field that's going to concat the name and the category along with a hyphen in the middle. So let's copy that. Okay, so now it's getting all of the documents, but it's getting this project description, and it gives us the name and the category. Okay, so we're concatenating those together. Alright, so we're going to go ahead and stop here. These are the most common operators and aggregation. So in the next video I'm going to show you how we can start to update these documents as well as delete them. Alright, so up to this point we've inserted documents into MongoDB, and we've selected or found documents using multiple operators and cursors. Now I want to show you how we can update data and delete it. Alright, and we're going to look at some new operators. So before we run an update, I just want to paste in or insert a new project called test project, and we just have some data here. So let's go ahead and run that. Alright, and then if we do db.projects.find.pretty, you see that we now have that test project. So that's what we're going to be working with. Alright, so let's do a simple update. We'll say db.projects.update. Alright, and the first parameter is going to be the condition. Okay, we want to tell the system what document we want to update. Now usually you would do this by a unique field like the ID, like the object ID, but just to keep it simple we're going to do it by name. So we're going to say where name is test project. Alright, and then the next parameter is going to be what we want to update. Alright, so I'm going to include the name here, and I'll show you why in a second. The name we don't want to change. And then we want to change the category. Okay, so category, we want to change that to web programming. So let's go ahead and run that and see what happens. Alright, so you'll see that we get this modified 1, and if we do a find down here, you see we have our test project. Now notice that everything is now gone except for the ID, the name, and the category. Alright, so when you just run an update like this, it's going to replace the entire document with whatever you put here. That's why I put the test project, even though we didn't want to update that field. Alright, so this might be okay in some cases, but most of the time you're going to want to just be able to update a single field if you want, without having to put every single thing in. So for that we use the set operator. Alright, so what we'll do is let's copy, actually you know what we'll do is let's put this back to how we had it. So I'm going to grab all of this and we'll put that in the update like that. Alright, and then we'll run that. And now if we do a find, you'll see that test project now has all the data back. Alright, so let's say we want to update the category, but just the category. We don't want to have to enter all this other stuff. So what we can do is say db.projects.update, and the first parameter is going to be the same. We want to specify the name, which will be test project. Alright, and then the next one here, instead of just putting the field, we're going to use money sign set. All right, and set that to another set of curly braces, and then in here we can say category web programming. Okay, so let's try that. All right, so let's do a find, and now you can see that the category is now web programming, and it didn't delete any other data. It's all still there. All right, now what if we want to update a specific array value? Let's say that we want technologies, we want this to be HTML5 and CSS3. We want to edit these without having to, edit the whole entire thing. So we're going to copy this, what we just ran. And let me just put a comment in here. We'll say update array val. And what we want to do is just put some double quotes here. And we know that the key we want is technologies. So we'll say technologies, and then we're going to do .0. Okay, so that's going to get the first one in the array, which is HTML. And we want to set that to HTML5. All right, and then let's grab that. And let's say technologies 1, which will be the next one. And we want that to be CSS3. All right, so let's try and run that. Okay, now we'll do a find, and you can see now we have technologies, HTML5, and CSS3. All right, so what if we want to update an object value like the client name? Okay, so for that, let's copy this. And let's see, let's get rid of that. And then this is going to be client.name. And let's set that to, let's say, Brett Harold. Paste that in and do a find, and now you see we get Brett Harold. Alright, so that's how we can update object values. Now we can also push to arrays. We can push and pull. So let me give you an example of that. Alright, so let's see, for this, I'm going to just paste that in, and we want name test project, and then here we're going to say push instead of set. And then let's say we want to add a technology, so let's replace this with technologies, and let's add PHP. Okay, we'll save that, run it, and now you see that in technologies we now have PHP. Alright, we can also pull from an array. Okay, so all we have to do here is change that to money sign pull, and that should get rid of PHP. Okay, now you'll see that PHP is no longer in the technologies array. We can also do a pop. So we'll say pop from array, and what that does is it just pulls off the last element in the array. So we'll say pop, and let's say technologies 1. Okay, so notice that right now it's HTML5, CSS3, and JavaScript. If we go ahead and run that and look at it again, now it's just HTML5 and CSS3. Alright, so what if we try and run an update on something that's not there? Alright, so let's try that. We'll say update doc that doesn't exist. So db.projects.update, and let's say we want to update where name is equal to my project. Alright, and then in the next parameter we'll say we want name my project and category web design. Alright, so let's go ahead and copy that and run it. Okay, so we don't get an error, but you'll see that we have nothing matched, nothing modified. Alright, now if we want to make it so that if we do something like this and we want this to actually create, if it's not there, we can use upsert. Okay, so let's paste that in, and then all you have to do is go at the end here and add another parameter, and this will be the options. And we can add here upsert true. So now let's copy that, paste it in, and now you'll see that we get this upserted one, and it even gives us an object ID. So if we now do a find, now we have my project with a category of web design. Alright, so that's upsert. Now, in addition to update, we also have find and modify, which will do just that. It'll find something and then it'll modify it. Alright, so let me give you an example of that. So we're going to say db.projects.find and modify. Okay, and actually, you know what? This has to be camel case, so the and should have an uppercase A and this should be an uppercase M. So find and modify. I'm going to open up some curly braces, and then we're going to specify a query. So we'll say name, and let's say my project, and let's say update, and we'll do a set, and then let's say category. We want to change that to web programming. Alright, and let's see, we'll add an upsert as well. Okay, so let's go ahead and copy that and run it. And let's see, we get null. Oh, it's a lowercase p. Alright, so notice that when we run it, it returns it back to us. Alright, now notice the category is still web design because it actually returns it before it does the update. Alright, so it returned with web design, but if we do a find, you can see that now it has been actually changed to web programming. Alright, and this one is also here, this my project with the lowercase p, because we have upsert, and that's what we ran first. Alright, now finally, to remove documents is really easy. We can just say db.projects.remove and paste in our condition. So we'll say our name is equal to my project. Okay, so we'll copy that, paste that in. Removed one. Let's also remove the one with the lowercase p. And now if we do a find, you'll see that my project is gone. Alright, so those are some update queries and also how we can remove documents. We've now looked at most of the CRUD functionality, create, read, update, and delete. So in the next video, or in the next set of videos, I want to show you how we can create a web API, a RESTful web API using MongoDB and Node.js. Hey guys, in this mini project we're going to be building a movie database, okay, and we're going to have a RESTful API, meaning that we can make GET requests to it and it'll return JSON data from our MongoDB database through Node.js. We'll be using Node. We'll also be using something called Mongoose, which is an ORM that will allow us to interact with MongoDB through our Express and Node server. And we're going to build the API, the backend API, and then later on I'll show you how we can add a front end to it so that we can actually have a mini application in our browser to display movies and let us upload movies. Alright, so first thing we're going to do is you need to have Node.js installed. Alright, I already have it installed, and I've gone through it back in the Node section of this course. Very easy, just download it, install it, and you should be all set. Alright, Mongoose is going to be installed from NPM, so we're not going to worry about that just yet. We're just going to create our application structure first. Alright, so I'm going to go into my C drive, and then in projects I'm going to create a folder here, and let's call this let's call it Mongo Movies. Alright, and then let's go ahead and open that up, and we're going to create a file here. Actually no, we'll just run npm init. So let's open up a command line, and I'm going to actually open up another one because this one I want to use for our Mongo shell. Alright, so let me just open up another one. Okay, so we're going to navigate to that folder. Projects, and then Mongo Movies. Alright, and we just want to run npm init, and that'll create a package.json file. Okay, it's just going to ask us a couple questions. Okay, so we're just going to enter through these. The name, Mongo Movies, that's fine. Version, description, say simple movie app. Entry point, we're going to say app.js, and then we'll just enter through the rest. Alright, and you'll notice that it created a package.json file. So I'm going to open up that folder in Sublime as well. So C drive, projects, Mongo Movies. Okay. Now we want to install a couple dependencies, so let's go back into this command line here, and we're going to say npm install, and we want a couple things. We want Express, we want body parser, and Mongoose. Okay, and then we're going to do -- save, because that'll add it to the package.json file. Alright, so now you'll see that those have been added over here in the package.json file. Now let's go ahead and create a new file over here, and we're going to save it as app.js. Okay, and that'll be the main entry point for the backend. So we're going to bring in a couple things. We want to say var express, and save that, or set that to require express. Okay, let's bring in the body parser, and we'll set that to require, and in here we'll put body / or dash parser, and let's also bring in Mongoose. Alright, so now what we want to do is add the middleware for body parser. So for that we're just going to say app.use, and in here we'll say body parser.json. Okay, we want to be able to parse JSON. Alright, we actually need to add our app variable right here. That's going to instantiate Express. Okay, and let's see, we want to be able to run the server, so let's do app.listen, and we'll listen on port 3000. Okay, and then let's just put a callback here. We just want to do a console.log, and we'll say server running on port 3000. Okay, so let's see what happens if we save that and we run node app and we have our server running. Okay. Now we're going to create a folder called routes here. Alright, so let's say new folder, routes, and let me just refresh that. Okay, so inside routes we're going to have a file, and we're going to save this as index.js, and we're going to create another one and save that. Let's see, we'll save this as movies.js. Okay, let me just refresh that. Now in our app.js we need to create, we need to require those files, so we're going to go right here and let's say var routes, and I'm going to set this one to the index. So that'll be require dot slash routes slash index. Okay, and then we'll have one for the movies as well. Okay. And then down here we'll set up the actual what the URL route should be. So let's do app.use, and for this, for slash, which represents the home page, we're going to put in routes, and then app.use, and this is going to be for our API, so we're going to say slash API v1 slash movies. Okay, and that's going to go to movies. Alright, so this will be our API URL. So let's save that, and then we're going to go into index.js, which is in the routes folder, and let's bring in Express. Okay, we're also going to bring in the Express router. Express.router. Okay, let's create, we'll handle a GET request to the home page, or slash. So this will be a function, and this is going to take in a couple parameters. It's going to take in request, response, and next. And then in here, let's just do res.render, not render, res.send, and we'll just say index. Okay, then we have to export this with module.exports equals router. Alright, and this just makes it so that this stuff is, it can be accessed outside of this file. Alright, let's save that and then copy that and then go into our movies file, and let's go ahead and we're going to keep the slash because that's going to pertain to this right here, this route. Alright, and then let's just, for now, we'll say movies API. Alright, and we'll save that. So let's go and restart the server. So node app, and then if we go to HTTP localhost 3000, we get index. If we go to localhost 3000 /API /v1 /movies, we get our movies API. Alright, so in the next video what we want to do is set up Mongoose. We're going to set up a model for our movies collection, and we ultimately want to be able to spit out the JSON content here for our API. Alright, so we have our node server up and running, and we have our routes to the movies API. Now what I want to do is implement Mongoose, which is an ORM that'll allow us to use our MongoDB database in our application. And we're going to set up models. Okay, now we don't need to set up models with NoSQL databases, but with Mongoose it's a really good idea, and it really helps you really define the data structure in your database. All right, so we're going to create a folder here, and we're going to call it models. Just refresh that. And inside models, we're going to create a file, and we're going to save it as movie.js. All right, and I like to give my models an uppercase. Start them with an uppercase. All right, so inside of that movie.js, we're going to bring in Mongoose, set require, okay, and we're going to set up our movie schema. Okay, now, like I said, NoSQL, it's schemaless, meaning at the database level you don't have to create your schema, but with Mongoose we're going to set it at the application level. All right, so let's say var movie schema, and we're going to set it to mongoose.schema, and we're going to pass in some curly braces, and we want to put in our fields. So let's put in a title. Okay, set that to an object, and we're going to put the type, which will be a string. Okay, so we want our movies to have a title that's a string. Let's also give it a description. Actually, let's call it plot. I think that makes more sense. Okay, that's also going to be a string. Okay, I also wanted to have a cover, which is just going to be a link to an image to a movie cover. So that'll be a string as well. Okay, let's also give it a genre. And let's do a release date. Say release date, and let's set that type to date. Let's do one called actors as well. Actually, I'm going to put that up here. Do it above the date. Alright, and I want this to be an array. So we're going to say type, and we'll set that to brackets. Okay, I'm pretty sure that should work. Or actually, we'll say array. Okay, make sure we put a comma right here, and then those are the fields that we could always add more later on. MongoDB is obviously very flexible, so we can do that if we want. All right, now down here, let's create a variable called movie, and we're going to say module.exports. And we want to export mongoose.model. Okay, and then we're going to pass in here movie, and then the schema, which is movie schema. Alright, so we're going to export that, then we'll have access to this movie value, this movie object outside of this file. Now, I want to create the methods or the functions that will interact with our database inside of this file as well. So let's go down here, and we're going to, let me just make this a little wider. We're going to say module.exports.getMovies. Whoops, I don't want to do that. I want to set it equal to function. Okay, and let's pass in here a callback, and let's also do a limit. Okay, we'll make it so that we can set a limit, and then all we have to do here is say movie.find and pass in the callback, and then .limit and pass in that limit value. Alright, and that's it. So we should be able to use this get movies outside of this file. Alright, let's save. And before we go on here, I just want to go to the Mongo shell. Okay, so I'm in my Mongo bin directory. I'm going to say Mongo. Alright, and we want to create a database, so we'll say use, and let's call it Mongo Movies. Okay, switch to DB Mongo Movies. Now let's create a collection with db.create collection, and we'll call this Movies. Okay, so now we have a movies collection. Now let's do an insert. We'll say db.movies.insert, and let's pass in a title. Okay, and I'm just going to grab a movie from IMDb. Alright, so let's see. Let's get The Exorcist. Alright, so let's go back to our Mongo shell. And we'll say The Exorcist. That's the title. Let's do description. Let's see, do they have a description? Whoop. Yeah, we'll grab this right here. Okay, paste that in. And let's see, what else do we need? A cover. So for the cover, let's see if we can get this cover here. We'll say open image in new tab, and then we'll just grab this, the URL. Okay, we'll go back to our command line and paste that in. Oh, let me just fix that quote right there. Alright, so make sure that that's wrapped in quotes. Okay, so after the cover, we have the genre, which will be horror. And let's see, we have actors, which will be an array. So we're going to open up a set of brackets. And let's see, this is actually, looks like it's a TV series, but that's fine. Alright, so let's see, we'll grab this guy. Alfonso Herrera, Ben Daniels. Make sure these are in quotes. Okay, we'll just use those two for now. And then finally we want a release date. So let's see, release date. And that will be a date, so we're going to say new date, and let's just put in here 2016, and I'm just going to make something up. We'll just say 10/11. Alright, so hopefully that works. Let's go ahead and click enter, and we get inserted 1. Alright, so we'll do db.movies.find. And there it is. Alright. Now I'm going to enter one more. So I'm just going to put that in and then just change some stuff around here. And I probably should have done it in my editor first, because this is kind of a pain. But that's alright. Alright, so let's see what else we got here. Let's do Deepwater Horizon. Okay, description. We're going to want to just delete this one. Okay, let's go grab that one. which is right here. We'll copy that and paste that one in. Okay, then we have the cover. Okay, so let's grab this. We'll say open image in new tab, and we'll grab the URL. Okay, paste that in. Genre is what? I think it's a drama. And then actors, I know it has Mark Wahlberg, so we'll put that in. I think that's how we spell it. And let's see what else. Kurt Russell is in it, so we'll add him as well. Okay, and then release date, let's just say 11/11. Alright, so I won't put you guys through that again. We have 2 movies, that's good enough for now. So what we want to do is make sure that this movie model is saved, and we're going to go to routes, movies.js, and go to where we have this slash. And actually, first of all, we want to bring in our movie model, so we can say var movie, and we'll set that to require / models, because we want to go into the models folder, and movie. Alright, this needs quotes. Okay, so now we should be able to use this movie variable. So we want to call the get movies function, so we'll say movie.getMovies, and that's going to take in a callback. Okay, and this callback is going to take an error if there's an error, and then also the movies that will be returned. Alright, and then first thing we want to do inside here is check for the error. So if there's an error, then we'll stop everything. We'll say res.send, and we'll send the error message. Alright, if there's no error, then let's do res.json. Okay, we just want to return the JSON. And remember, it has, actually in here we'll pass in movies. And then it also has a limit parameter. If we look right here, that was our callback. We can also have a limit. So let's just put in here, comma, and then 10. Alright, so now what we want to do is go back to app.js. And let's go under where we required mongoose, and we need to connect. So we'll say mongoose.connect. Okay, and in here we want to put MongoDB localhost / Mongo Movies, which is the name of our database. And then let's create a variable called db right here, and we're going to set that equal to mongoose.connection. Yeah, mongoose connection. And let's do db.on. Okay, we want to make sure there's no errors, so we'll say on error. Then let's do console.log. Console.log. No, not console log. Let's do console.error.bind. And in here we'll pass in console, and then we'll say connection error, like that. Okay, and then let's do db.once. And in here we're just going to say when it opens, then we'll just console.log, and we'll just say MongoDB connected. Alright, so let's save that, and let's restart the server. Not that one. Okay, we'll do node app. And what's this missing? Oh, we're missing closing parentheses right here. Alright, so we get MongoDB connected. And now if we go to here and reload, now we're getting our movies. Alright, so we're returning all the movies in the database with our API. Okay, and we're doing it in JSON format. So in the next video, we're going to continue working on the API. I want to be able to get a movie by its ID, so we can get a single movie, as well as being able to insert a movie through a post request. Alright guys, so we have the API set up, and we're able to fetch all of our movies through this URL here. Now I want to make it so that we can get individual movies by putting the ID inside of the URL. So let's go into our routes, movies.js, and we're going to create another route here. Let's put a comment. We'll say single movie. For this one, we'll say list movies. So we'll do router.get, and this is going to be slash, let's say /:ID, and then we'll put our callback. Okay, that's going to take in request, response, and next. And we're going to call movie, our movie model, dot get movie by ID, which we still need to create. Alright, and then we want to pass in the ID from the URL, which we can get using request.params.id. Okay, that'll pass in the ID. Then we have our function, our callback, and here we'll pass in error and movie. Okay, we'll check for the error. If there is, then we're just gonna res.send, and if there's no error, then let's do res.json, and we'll just pass in movie. Alright, so let's go into our movie model now, and we're going to create that method down here. We have to export it. Module exports dot get movie by ID. Okay, that's going to equal a function. Alright, and that function is going to take, let's see, it's going to take in the ID and then the callback. Alright, and then in here, all we have to do is say movie, and then Mongoose has a function called find by ID. So we're going to use that. Movie.findByID, pass in ID and the callback. Alright, so let's save it, and then let's go over here. Actually, we need to restart the server first. So let's see. Control C. Okay, now we're going to grab one of these IDs. So let's grab this, copy that, and we're going to go to this same URL, except we're going to say slash and then paste in the ID. And there we go. So now we're seeing all the information just for the Exorcist. Alright, so that's exactly what we want. So we want to be able to insert a movie as well. Alright, so that'll have to happen through a post request. So let's go to, let's see, we're going to go to our routes, movies, and right here, let's say add movie, and this is going to be router.post, okay, because this is going to be if it's a post request. Alright, and then right here, this will just be slash because we want to just make a post request to this URL here. Alright, so let's do function. Okay, we'll grab that. And let's say, now what we'll be doing is getting the data from a form. But for now, since we're not submitting a form, we're just going to add the data through here. We're going to add some static content. So we want to say, let's do movie. Actually, no, we'll create a variable called new movie, and we'll set it to new movie, which is from our model. And let's pass in here some curly braces, and let's see, we'll do title, and I'm just going to grab something from here again. Let's grab the accountant, and let's see, so title will be the accountant, and what else do we have? A plot, I believe. Was it a plot or a description? Oh, it is a description. I thought we changed it to plot. Alright, so description. Okay, let's grab that. And then we have, what else? Title, description, cover. So for the cover, let's do open image, and we'll just grab that. Okay, then we have genre, let's say drama, and let's see, is that it? Genre, and then actors, and we should also have a release date. Yep, okay, so actors. Okay, we know that Ben Affleck is in it. I think that's how we spell it. Release date. Let's set that to new date. Say 1201. I think that should do it. That should create a new movie. So now we want to take this new movie and we want to call .save. Alright, and then inside here put in a function. So this will be error and movie. And let's check for the error. Okay, if there is one, then we're just going to do res.send. If there's not, then let's just, let's see, we'll console.log movie. Alright, so let's save that, and we're going to restart the server. Okay, now to make a post request, you need to use some kind of client. We're going to use REST-easy for Chrome, which is just a simple plugin. If you don't have it, just go ahead and install it. I already have it, so I can launch it here. And we're just going to grab this URL. And actually, you know what? I don't want to console log this. I want to send it. So right here, I'm going to send the JSON, so res.json. Alright, and I just want to restart the server real quick. Alright, so now let's paste that in here, that URL. And we want to make sure we choose post request. Okay, now we have the content is just static in that file, so we're not going to send anything here. We're just going to click this send button. And then down here you can see we get the accountant and all that information back. And then if we go to this URL and reload, we now have, where is it? Where is it? Right here, the accountant. Alright, so that's good. Now if we don't want this to be static, we want to be able to actually add the data through here and send it to the server. Then what we can do is set, let's see, we're going to create a variable here called movie, and we'll set it to request.body. So basically set it to whatever is being sent. Alright, and then instead of putting all of this in here, we'll just put in movie. Okay, so we'll save that and restart the server. Okay, and then let's reload this page. Alright, so what we want to do, let's look for a new movie. Let's see, we'll grab this. Okay, the girl on the train, so let's grab that URL, paste that in here. It's going to be a post request. Now we need to set the application type, or the content type, right here. And we're going to set that to application/JSON. Alright, and then in the body here, we're going to put in a set of curly braces and then build up our object. Alright, now this needs to be formatted correctly as JSON, so we need to put quotes on both the key and the value. So we'll say title, the girl on the train, description, okay, let's grab a description, paste that in. Okay, then we have the cover. Grab that, paste that in here. Okay, genre. For that we'll say thriller. And what else? We have, let's see, genre, release date, actors. So let's say release date. And I'm just going to format this as a string. We'll say 2016 12/13 or 12/12. And then finally we have actors, which is an array. So let's see, Emily Blunt, Haley Bennett. Alright, so that looks good. It looks formatted correctly. I'm just going to copy it just in case, and then let's go ahead and try to send it. Alright, so we got unexpected token. Let's see. Let's just make sure this is formatted correctly. Oh, invalid JSON. String should be wrapped in double quotes. Let's try that. So this array, these strings should be in double quotes. Alright. So let's try that. Good. We get a 200 response, which is good. So let's go back here and reload. And there it is. The girl on the train. Okay, so we can now post data and insert it, and we can also get individual movies. So in the next video, I'm going to show you how we can update and delete these movies using HTTP requests. Alright, so I will see you then. Alright guys, our movies API is almost complete. We can now find all movies, we can find a single movie, and we can post and insert a movie. So now we want to be able to update and delete. So this isn't going to be too difficult. We're going to go to our routes movies file here, and we're going to update movie. Now this is going to be a put request because it's an update. So router.put, and for the route here it's just going to be /:ID. Alright, because we need to put the ID of the movie we want to update. Alright, and then let's do function. Okay, we'll grab our parameters. And from here, we need to figure out what movie we're going to update. So we're going to put that in a variable called query. Alright, and we're just going to say we're _ID. And we want to set that to the ID that's coming in through here, through the URL. And we can get that with request.params.id. Okay, now for the data that we want to use to update, that's going to come from request.body. So I'm going to put that in a variable as well. Alright, then what we want to do is take that movie model object and call update. And in here we'll pass in the query. Okay, this next one is going to be our set. So I'm going to say set body. And then this is the options, which we don't have any, so I'm just going to put an empty set of curly braces. And then finally we have our callback, which is going to take an error and movie. Okay, we'll do the same thing we did up here. Check for the error and then just respond with the JSON content. Alright, and that should do it. So let's save it and make sure you restart your server. Okay, and then we're going to go back to REST Easy, and let's grab this, put that in. Now remember, we also need the ID, so we're going to say / and then I'm going to grab the ID of the accountant, which is right here. And what I want to do is I want to update it from, you can see it has a drama genre. I want to change it to thriller. So let's go over here and paste the ID in. And then we're going to choose a put request. We're going to add a header because we need to define the content type. And that's going to be application /JSON. And then in the body, we put what we want to update. So I just want to change, not category, genre to thriller. And that should do it. So let's try to send, and you can see we get this modified 1. And then if we go back over here and reload, you'll see that the accountant is now has the genre of thriller instead of drama. Okay, so we were successfully able to update it by making a put request. Alright, so the last thing we want to be able to do is to delete movies. Okay, so we want to say router, and this is going to be a delete request. Okay, router.delete. And for the route, it's going to be /:id. Put our function in. Okay. And we're going to grab the same query right here. Paste that in. And let's see, we're going to say movie.remove. And we're going to pass in the query. And then we'll do our function. And then we just want to put in here error, and we're going to check for the error. And if everything goes okay, let's do res.json, and let's just put in an object in here, and we'll just say, let's see, we'll say message success. Alright, let's try that. So we'll save, go back to rest easy. Okay, let's also restart the server first. And for the URL, we're going to do this. And remember, we have to put the ID as well. So let's say we want to delete the girl on the train. So I'm going to grab that ID and put that here. Okay. Headers, let's do, actually we shouldn't need to do that. We shouldn't need the headers. Let's just try and run this. So we got an OK. Let's go back here and reload. And it's still there, so something didn't, oh, we didn't choose delete. There we go. Message success. And if we go over here and reload, now it's gone. So we can now create, read, update, and delete movies through our RESTful API. Hopefully you guys enjoyed this project, and thanks for watching. Alright, so we've talked about MongoDB, which is a NoSQL database. Now we're going to move on to another NoSQL database called CouchDB. So CouchDB is an open source database software that focuses on ease of use and having an architecture that completely embraces the web. Okay, unlike a relational database, a Couch database does not store data and relationships in tables. Instead, each database is a collection of independent documents. So it is in fact a document database like MongoDB, and it uses JSON-like documents to store data. So here's some advantages and reasons why someone would want to use CouchDB. So it has easy replication of a database across multiple server instances. Alright, it can be ran in cluster mode or on a single node. It has fast indexing and retrieval, REST-like interface for document insertion, updates, retrieval, and deletion. It runs on JSON-based document format, easily translatable across different languages. It uses multiple libraries for your language of choice, and it also has subscribable data updates on the changes feed. Alright, so these are all just some of the advantages of using CouchDB. Now, CouchDB uses something called Couch Replication Protocol, and this is a protocol for synchronizing JSON documents between two peers over HTTP, or Hypertext Transfer Protocol. Alright, and it does this by using the CouchDB REST API. It's based on the CouchDB MVCC data model, which is multi-version concurrency control. It replicates in a source to target method and retrieves basic info using a GET request to the database. Okay, the GET response must contain two mandatory fields, and that's instance start time, which is the timestamp when the database was opened, and then also an update sequence field, which is the current database sequence ID. All right, any other fields aside from those two are optional. So here is an example of the GET request and response. Okay, so this is a GET request using the HTTP protocol version 1.1. The content type is application JSON. It also has the host and the port, and then the user agent, which is CouchDB. All right, and then the response gives us info like the date, the server, and then a response object with fields like data size, database name, disk size, the number of documents, things like that. All right, so that's what a common GET request and response will look like using the replication protocol. Now, before replication is started, the replicator must generate an ID. This is used to track history, resume and continue previously interrupted replication processes. All right, now this stuff that I'm showing you, this isn't stuff that you really need to master. It's just kind of showing you how this all works. So CouchDB uses the following factors when generating an ID. So a persistent peer UUID value, and this is universal ID. For CouchDB, the local server UUID is used. All right, source and target URI, and if the source or the target are local or remote databases. We also need to factor in if the target is needed to be created, if replication is continuous, any custom headers and OAuth headers if they exist, and then the filter function code if that's used. All right, so again, don't worry too much about this stuff. I'm just trying to give you an idea of how the Couch replication protocol works. All right, now when you're using CouchDB, there's two setup types. There's single node, which obviously uses a single node. It's the most common setup and the easiest to work with. It works like any other database behind an application server of your choice. It doesn't take advantage of things like new scaling and fault tolerance, all right, because it's only one node. You can also set up a cluster, which runs a single logical database on any number of servers and virtual machines. This is much more advanced. It does offer a much higher capacity and availability without changing APIs, and has all sorts of node management features. All right, now we're not going to get into clusters because that's well beyond the scope of this course. We're just going to be working with a single node, single database. Now, when we install CouchDB, we'll be working with something called Foxton, which is a web UI for CouchDB. It can be installed via npm, node package modules, as well as the Windows CouchDB installer. And it's used to do things like create and manage databases, create and manage documents, view logs and statistics, manage tasks, and create views. All right, so it's actually very helpful, and it's really easy to use since it's a graphical user interface. So CouchDB uses something called views, which are a way to filter or query data in the database. They're typically written in JavaScript, but can be written in other languages as well. All right, each view maps keys to values inside a document, and they are tied to something called a design document. All right, this can all be done within Futon or Foxton, so we'll get to this later. I'm not going to talk too much about it now, but here is a very simple example of a view, and what this will do is display all event documents. All right, documents that have a doc type of event, and it's just a simple function in JavaScript. This emit right here, this emit function will take in two parameters, a key and a value. And the key is the document ID, the value is the entire document itself. All right, and the value can also be null. Okay, but I'm not going to get too much in. All right, guys, so we're going to go ahead and get CouchDB set up. Okay, this is going to be pretty easy. We're using Windows, and if we go to couchdb.apache.org, you'll see this download button here. We're going to click that, and we're going to download CouchDB 2.00. And let's see, we're going to click on the Windows, and that's going to download an MSI installer, so we're going to save that. Alright, so now that that's downloaded, let's go ahead and open it. And we'll click Run, and it's just a Windows installer. Just click Next. We're going to accept the license agreement. Alright, and it says Apache CouchDB must be installed into a path with no spaces. Alright, so we'll click Next, and you can see the path is going to be d/CouchDB, which I don't want that. I actually want it to be in my C drive. So I'm going to choose C, and let's say new folder, CouchDB. Alright, I'm not sure why it chose D by default. That's kind of weird. Alright, so let's go ahead and click Next and install. Okay, we'll let that run. Alright, so it says that it has complete. Let's click Finish. Now, it should have started as a service, so to check that out, let's go and see if we can go to Foxton, which is going to be HTTP localhost, and it's going to be port, so we want a colon and then say port 5984/_utils. Okay, so that says up here Project Foxton. Now, if you've used CouchDB in the past, you may remember Futon, which is something like this. This is completely replaced Futon, and it has additional functionality. It's actually really nice. So we're going to go ahead and stop here. The purpose of this video is just to get this installed and set up on Windows. So in the next video, I'll show you how we can start to create a database and start to work with some documents. Hey guys, in this extra video I'm going to show you how to install CouchDB on a Linux Ubuntu machine. Alright, so first thing we're going to do is update the system with sudo apt-get update. Okay, you're going to need your password. Alright, now we're going to install the software that allows us to manage the source repositories that we need. So we're going to say sudo apt-get install software-properties-common, and we'll just add a -y flag because we want to answer yes to any questions. Alright, so the next command we're going to do is sudo add -apt repository. Okay, we want to do PPA:couchdb/stable, and we'll add the Y flag. Alright. So what that did is it added the PPA that will help us fetch the latest CouchDB version from the appropriate repository. Alright, so now we're going to do another update. And once that's done, we can proceed to actually install CouchDB. Alright, so now let's do sudo apt-get install CouchDB-y. Okay, and this should install CouchDB and Foxton on excuse me, on our server. Alright, now to check it, we can use curl. We'll say curl localhost, and the default port for Couch is 5984. And there we go. So we get this CouchDB, we get a welcome with a universal ID, and it gives us the version number and the platform, which is Ubuntu. Alright, so that's how we can install CouchDB on Linux, and we should be able to also access Foxton through the browser. So let's try that out. Alright, so let's go to HTTP, and we want to localhost, and that's going to be on port 5984/_utils. Okay, alright, so it's actually Futon with this installation, which is similar to Foxton, where we can create our databases, we can insert documents and things like that. Alright, and we'll be taking a look at this further on through the course. Alright, so that's it. I'll see you in the next video. Alright, so we installed CouchDB on Windows, and we're at localhost 5984/_utils, and that shows us the Foxton user interface. Alright, so I just want to do kind of a little tour of this interface. This landing page that we see, this is where our databases show up. Alright, we don't have any at the moment, that's why we're not seeing any. Alright, if we want to create a database, we can do that by clicking this link up here. But before I do that, I just want to go over some other things. So if we click Setup, you'll see that we have the ability to run a little wizard here, and we can configure a cluster, which would be a database that we want to run across different servers or different VMs. It's more of an advanced setup, and we're not going to get into that. What we want to do is configure a single node. Alright, so if we go ahead and click that, it'll ask us to specify some credentials. So let's put in a username here and a password. Okay, make this a little bit more secure. And the address, we're going to leave that at 000, and 5984 is the port. We're going to keep that and just click Configure Node. Alright, and then you'll see we get this message that says CouchDB is set up. Alright, we're not going to get into replication yet. What I want to do now is go down to Verify, and if we click the Verify installation, it'll just check a couple things. If we can create databases, documents, all of that, if we can do replication, and it looks like the status is good on all of these. Alright, documentation, you have a bunch of helpful links here. Admin, this is where you can change your password. You can also add new admins if you want. Alright, active tasks, this has to do with different tasks in the database. Okay, this includes background tasks that have to do with things like index building, compaction, replication, and so on. Okay, we also have a configuration tab, and this has all the different config options. You can also configure cores, and that is cross-origin resource sharing. So it lets you connect to remote servers directly from your browser. You can host browser-based applications on static pages and talk directly with CouchDB to load your data. Alright, it's currently disabled, and you can enable it if you want by clicking this button, but we're just going to leave that for now. And replication, this is where we can set up replication. Basically take one database, replicate it to another, whether local or remote, but we'll look at that a little later. So let's click on databases, and now you can see since we ran that setup, it created some stuff for us. Users, this is going to hold all of our different users. Replicator, which will hold all the replications, metadata, and then global changes. Alright, so let's go ahead and create a database, and let's just call it Acme. Actually, no, that's a search box. We want to click Create Database and then click Acme. Okay, you can see we get this little messaging system up here as well, which is nice. Alright, so database created successfully. Now you'll see we have these menu items over here. This is going to show us all the documents that we have, which we don't have any yet. We can run a query with Mango, which I'll show you later. Permissions, changes, and then design documents. So let's go ahead and add a document. We'll click the little plus here and we'll say new doc. And you can see it's in JSON format and it gives us an underscore ID field. So let's add in here, let's say product. Okay, and we're gonna have a database that has some products along with different prices from different stores or different retailers. All right, so let's say product, and we'll call this Sony HD TV. And then here we'll say prices. And actually that's going to be an object like that. And let's say Best Buy. And we're not going to use quotes here because these are going to be prices. So let's say $699.99. Okay, and then we'll have another retailer, let's say Walmart. And Walmart has it for, let's say, $6.59. And then let's do Target, which has it for $7.10. Okay, so there's a document. Let's go ahead and click Create. You'll see it says Saving Document, and now we can see it over here. Alright, we can easily edit it if we click this little pencil icon. Alright, so you can see we have our ID, we have the fields we added, and we also have this underscore rev, alright, which is the revision. Now, the rev has to do with the MVCC, or multi-version concurrency control. It holds the MVCC token, which is used for optimistic concurrency detection. Alright, and that might sound like gibberish, but we're not going to worry about it for now. Just know that it does create that automatically. Alright, so let's go and create a couple more. We'll say new document. And for this one, we'll say product. And let's see, we'll say Xbox One. And then we'll have our prices. Oops, that's going to be an object. Alright, so let's do Best Buy. So for Best Buy, we'll say $2.99. Walmart, we'll say $2.65. And Target, these aren't real prices, by the way. We'll say $3.10. Alright, and I'm just going to copy this. Alright, we'll click Create. Let's add one more, new doc. Paste that in, and then let's change this to, we'll say Samsung Galaxy 6. And we'll change the pricing here to $4.99. We'll do $3.85 and $5.10. Okay, so now we have these three documents. We can also choose to show the fields here. If we go to Options and then say Include Docs and run query, and now you'll see the product as well as the prices and anything else that we add. Alright. And in addition to viewing the JSON, we can click this table here, and that'll show us it in table format. Okay, we can just filter through here if we want. We can go ahead and we can delete them. Alright, we can copy them if we want. Just a different way to view things. We also have this API button right here. If I click that, and it'll just give us this our URL / all docs, include docs equals true. And if we click View JSON, it'll open up another tab, and it actually makes a GET request and gives us a response with our different documents here. All right, along with the total rows and the offset, and then rows, which is an array of objects. All right, and we can make that request from curl or from a web application, whatever that we can use to make GET requests. All right, so that's how we can create databases, create documents, we can filter through them, we can edit them, and we can secure our Foxton installation. All right, so thanks for watching, and I'll see you in the next video. Hey guys, in this video we're going to go back to our Linux installation and just work with Futon a little bit. Okay, so Futon is the older user interface to work with CouchDB. This is CouchDB version 1.6.1. Foxton has now replaced Futon in CouchDB version 2. Alright, but I figured I'd throw this in just as kind of an extra video. Alright, so when we initially enter the interface, down here you'll see that it says everyone is admin, and it has a fix this link. Okay, let's go ahead and click that, because we want to have an authentication here. So we'll say username admin and then put in a password and click create. Alright, and this is nothing. So now we actually are logged in as admin. Alright, you can see we can log out as well. So let's click on verify installation and click this link here, and it says your installation looks fine, time to relax. Okay, so let's go back to overview, and you'll see it created a users and a replicator. Now we're going to create a new database, and let's call this Acme. Click create, and from here we'll say new document, and it gives us an underscore ID field. So let's go ahead and click the check, and then we'll say add field, and here we'll say product, and here we'll say Sony HD TV. Click the check. Okay, we'll add another one called prices, and in here let's put in an object. We'll say Best Buy. Best Buy, and let's put a price of $6.99. Okay, then we'll say Walmart, and we'll say $6.50. And Target, we'll say $7.10. Okay, check, and that looks good. Let's click Save Document, and now we have a document. You'll see it also added the underscore rev field as well. Alright, so we have a database called Acme along with a document. And I'm not going to get too much more into this. I just wanted to kind of introduce Futon in case you are using an older version of CouchDB. Alright, so that's it. Thanks for watching, and I'll see you in the next video. Alright, so we created a database with some documents. Now we're going to dabble in views. Views are useful for filtering documents, extracting data, ordering data, as well as making calculations. Alright, so views are basically made up of map functions and optionally reduce functions. Alright, so if you have experience with map and reduce, this should be pretty easy. If not, we're not going to get too deep into it. I just want to show you some simple examples. So let's click on our Acme database here. And if we go up to where it says all documents, and we click the plus icon here, and we say new view. From here, let's give it a name. Now, this is going to be very simple. Actually, you know what? Let's just run this. Okay, you can see it gives us a default map function down here. Alright, so we'll just call this view1. Alright, and what this is it's a map and reduce. It's a map function. You can optionally have a reduce, but we're not going to deal with that yet. So it takes in the document as a parameter, and then we call this emit function, which takes in what we want as the key, and then what we want as the value. In this example, it's going to take our documents and give it the ID as the key, and then just the number 1 as the value. So let's see what happens if we go ahead and run that. You can see it says saving view up here. and it might take a couple seconds. Alright, so this is what we get back. You can see that we have our ID, which is the actual ID, the key, which is also the ID because that's what we specified, and then the value is just the number 1. Okay, so this isn't very helpful, but this is what's generated with that function that we saw. So let's do something a little more useful. We'll go ahead and add another view, and let's call this view 2. Now, instead of using just 1 here as our value, let's say we want to get the product. So we'll say doc.product. Alright, and let's actually change the view to, we'll say get product. Okay, so now you can see we have the key, which is the ID, and then the value is the product name. Okay, and we also have these listed under here, under the design documents here. Alright, now let's say we want to use something different as the key. So we'll say new view, and we'll call this product name. So down here, let's change it from doc.id for the key to doc.product, and then let's get the prices for the value. So we'll say doc.prices. Alright, so let's go ahead and run that, and now you'll see that the key is now not the ID anymore, it's the actual product, and then the value is the different prices, okay, and the different retailers. Now we can also use standard JavaScript functions as well. So if we were to create a new view, and we'll just call this view 2, and let's say we just want to get the product again, and we can actually use a function like .to lowercase. Alright, so if we were to create that, now you can see that each value, each product is now all lowercase. So we can use functions like that as well, which is really helpful. Alright, we can also test for conditions. So what I'm going to do is, in one of our products here, let's see, we're going to, and you'll see that when we click all documents, all of our views also show up here. Okay, and I'm just going to get rid of some of these. Let's delete these. We'll delete the get product, and let's see, product name, view 2, and view 1. Just delete these. Alright. Oops. Okay, so let's see, make sure our data is still there. We'll choose this include docs. Alright. So let's say we want to add to this right here, this Sony HD TV. We're going to add another property here called is_special. Okay, so maybe it's a special product on sale or something, and we'll set that to true. Alright, so let's save that. Now that the Sony HD TV is a special, the other ones are not. So let's go back and let's say new view, and let's say we just want to get the doc.product as our value, but we only want the ones that are on special. So we'll say if, and we'll say if doc dot is special, and just wrap that. Okay, and then we could call this is special and create, and now you'll see we're only getting the Sony HD TV because that's the only one on special. Alright, so we can use those if statements kind of like where clauses in SQL. Alright, now let's do something a little more advanced. I'm going to just delete this view. Oh, and by the way, we can also click this API, and it'll give us an API URL we can use to make a GET request to get that that view or that design document. Alright, so let's go ahead and delete that. Okay, and then we're going to do new view again. And down here, what I want to do is we're going to set var shop. What I want to do is get a list of prices. Okay, I want to use the price as the key, and then the value will be the product and the retailer. Alright, so we're going to say var shop price value, and then let's do an if statement here. Okay, and I'm just going to get rid of this. So in here we'll say if doc.product and doc.price or prices. So what this is doing is making sure that it has a product or product name and also has prices. Alright, and then we're actually going to do a for loop. Alright, this is just standard JavaScript. So we're going to say for shop in doc.prices. Okay, we're going to loop through these prices, and then we're going to say price equals doc.prices, and in here in these brackets we're going to put in shop. Alright, and then in the next line we're going to set value to a set of brackets, and we'll say doc.product shop, and then we're going to do our emit. Okay, we want to emit the price and the value. Alright, so let's for the index name, let's say prices. Alright, and then we'll just call this my design doc. Alright, so let's create, and now you can see we get for our key we have our prices. Alright, and they're sorted from lowest to highest, and for the value we have an array with the different retailers. Alright, I'm sorry, not the different retailers, but the actual product and that retailer for that price. Alright, and if we click API, view JSON, we can fetch that, making a GET request. Alright, and another helpful thing we could do if we want to make this descending, right in the URL, we can just say and descending equals true, and now you'll see Sony is now at the top. Alright, so you can add different parameters like that, and you'll see it says reduce equals false because we had a map but no reduce. Alright, and there's a limit of 20 which we could change. Let's say we want a limit of 2, and it only gives us 2. Alright, so that's how we can work with views and design documents. Hey guys, in this video I want to show you two things really. One, to set up a remote CouchDB database, and another to replicate. Okay, I want to replicate our local database to the remote. Now, there are services that will offer free CouchDB databases. IBM Cloudant is one of those, and there's also Iris Couch, but for some reason the URL is down, so I'm not sure if that still exists or not. But Cloudant is really nice. Just go ahead and sign up, cloudant.com. Okay, if you click sign up, you just fill out a form, add your username here, and then your host will be username.cloudant.com. Alright, once you fill out this form and sign in, you'll automatically get logged in. Alright, so I'm just gonna, I already have an account, so I'm gonna add mine here. And let's go ahead and sign in. Alright, and you'll see that the interface is very similar. It's just a different theme. We have a list of databases, our replication, analytics. There's also an account tab which has some stuff here. What I do want to do is for this CORS, I just want to, it's already enabled by default. I want to say that we want to accept requests from all domains. Alright, and then we'll go over to our local installation here, and let's click on replication, and we're going to choose from here the Acme database, which is local, and then we want to replicate to a remote database. So right here we're going to put HTTPS, and then we want the username and password. So the username colon and then your password, and then the @ symbol and your username again. And .cloudant.com. Alright, and then / and then the database name, which will be Acme. Alright, so let me just double check that. And then we're going to make sure that the create target is checked. And then let's click replication. Alright, so replication has begun. Okay, that's good. Now let's go over to Cloudant and reload. And now we have Acme. Alright, click on that, and you can see the My Design doc. The design document came over, as well as all of the different documents. Alright, if I click on options and then include docs, you can see that we have the TV, we have the Xbox One, and the Samsung Galaxy. Alright, so that's how easy replication is. And I just wanted to show you guys that real quick, and I'll see you in the next video. Alright, so curl is another method we can use to work with our CouchDB database. Now we're on Windows, so we're going to use this curl for Windows, which is available from confusedbycode.com/curl. And I'm going to go ahead and go down here, click the verification, and then I'm going to get the 64-bit with administrator privileges, which is free. There is a premium version with auto updates and easy SFTP, but we're not going to get that. Okay, we're going to just download that, and let's open that when it's done. Alright, so now we get this setup wizard. We're just going to go through that. Click finish. And now I'm going to open up a command line. Okay, and let's just do curl -- version, and you can see that curl is installed. Now we can use curl and say HTTP localhost and port 5984. Okay, so we get this response that says welcome, gives us the version, vendor. So we know that curl's working. We know that it is communicating with CouchDB. Now we're going to be using this HTTP localhost actually I want to use the loopback address, which is 127.0.0.1, and we're going to use it quite a bit. So what I'm going to do is put it into a variable. Alright, so what we can do is we can say set host, and we're going to set host equal to HTTP 127.0.0.1 port 5984. Alright, so now if we say echo, and the way that we can grab this is with %host%. Alright, and you can see that that value is in that host variable. Alright, rather than typing that out, we can just do this. Alright, so let's try curl host. Alright, so we know that that's working. Now, to get all databases, we can say curl, and we want to do this hyphen uppercase X and then get, okay, because it's a get request. And let's put in our host variable, and then we want to do /_all_DBs. Alright, and you can see that it's giving us all the different databases on our system. Alright, I don't like this Windows system, so I'm just going to go back to the C prompt. Alright, so what I want to do now is create a database. Alright, so we'll say curl X, and then it's going to be put, and we want our host slash, and then the name of the database. This is going to be customers. Alright, now when I run this, I'm getting this "you are not server admin." Okay, and the reason we're getting that is because when we were in Foxton, we went ahead and created an admin user. Alright, so we're not we're not implementing that when we're making these requests. So what I'm going to do is change the meaning of host. Okay, so we'll say set host, and this time we just want to include the username and password. So admin, which is the username, and then colon, and then the password. Alright, and then we want to do at 127.0.0.1. Okay, port 5984. Okay, so now that we have that, we should be able to now create the database. Alright, so now we get OK true. Alright, so let's look at all the DBs again, and now you can see that customers is in there. And even if we were to go to Foxton, you can see now we have this customers. So now I want to show you how we can insert a document into customers. Now we have to create our own UUID as the ID, and that's a long string of characters. So what we can do to generate one of those is we can actually say curl x get host slash or UUIDs, and that gives us one. Okay, instead of having to create our own. So I'm just gonna highlight that and Control C, which will copy it. And now we're going to insert a record or a document. So let's say curl x put host slash customers slash, and then we want to put in the UUID. So I'm going to just Control V to paste that in, and then we want to add the D flag, and then open up some quotes, curly braces, and this is going to be our object. So we want a name. I'm going to make this short. So we'll say John Doe, and then let's do an email. Email. We'll say jdoe@gmail.com. That's all we're going to do is a name and email. Now with Windows, we have a bit of an issue with the quotes. Alright, so we actually have to escape the quotes that are inside here with a backslash. Alright, so you want to put a backslash before each of these quotes. Alright, and I know it can be kind of a pain, but that's how it is in the Windows command prompt. You shouldn't have to do this in Linux. Alright, so that should do it. Let's go ahead and try to run that. And we get this OK true. We get the ID back, and we also get the rev. Okay, the rev ID. And if we go back into Foxton, well, it looks like we have to log in again. And we click on customers, and you can see we have, let's go ahead and click include docs, and we have name John Doe, and we have the email. Alright, so that worked. Now if we want to fetch that user here, we can do that with curl x get, and we want to put in our host slash customers slash, and then we just want that ID. Okay, paste that in like that, and it gives us him back. And you can notice that we have this underscore rev. Now we're going to have to include this if we want to update. Alright, if we want to update this document. So let's go ahead and do that. So curl x put and host slash customers slash put in the ID, and then what we want to do is we want to put a backslash and then our D flag, and then what we want to update it to. So let's put in a name, which is going to be the same, John Doe, email, oops. Let's change the email. We'll change it to john@yahoo. Alright, and then I'm also going to add another field here. Okay, we'll add a location. Okay, so location, we'll say NY. And we're also going to need to put the rev ID. So we're going to put that at the beginning here. Okay, so right here, let's do underscore rev. Alright, and then I'm just going to grab this, Control C, and a Control V. Alright, so that looks good. We just need to add our backslashes. Okay, remember they have to go before the quote. Kind of a pain. Okay, so let's go ahead and run that. Alright, so could not resolve host. Oh, we don't have to worry about that. It should have worked. If we go and we do the get, yeah, you can see that the email has changed, and he also has the location of New York. Alright. So the last thing I want to do is show you how to delete. So for that, we're going to say curl x delete. Put our host variable / customers / and then we want the ID. Okay, now we also want to put a question here and then rev equals, and we have to include that rev ID. So let's grab this, paste that in, and I think that should do it. Yep. So now that should be gone. Let's go ahead and do a get, and it's not found. Reason deleted. Okay, so that's how we can do CRUD functionality. We can create, read, update, and delete documents from CouchDB using curl. Alright, so we're on to the next part of the full stack web development course, and we're going to start to talk about technologies that aren't as mainstream. Alright, so we're going to start with Redis, and Redis is an open source BSD licensed in-memory data structure store that is used as a database, cache, and a message broker. Alright, now I didn't put this in the database section because although it has some similarities with technologies like MongoDB and CouchDB, it works on a fundamentally different level. Alright, it can be defined as a key value store, but it works in memory, not on disk. Okay, it uses built-in replication, Lua scripting, and different levels of data persistence. So we had a section on MongoDB and a section in CouchDB, which are both considered NoSQL databases. Redis is a NoSQL technology when it comes to the way it stores data and the way it retrieves data, but what is different is that it's memory-based and those others are disk-based. So Redis is also used for things like caching. Alright, unlike something like memcached, the data can also be persisted to a disk. So it's essentially a mix of something like MongoDB and then something like memcached, which we'll be getting into in the next section after Redis. Alright, so let's take a look at some of the data types that Redis supports. Okay, we have strings, which are the simplest type of data that we can associate with a Redis key. Hashes, which are basically a map between string fields and string values, similar to an object. Lists are groups of strings. Sets are unordered collections of strings, and then sorted sets are just that, collections of strings that are sorted. Alright, we also have more complicated data types that I'm not really going to get into, things like bitmaps, hyperlogs, geospatial indexes, That's really where Redis shines, is that there's a bunch of different data types that it can use. So Redis also can utilize transactions. Okay, transactions allow the execution of a group of commands in a single step. Now there's two extremely important guarantees when it comes to Redis transactions. Without these two guarantees, things like bank account transfers would be extremely insecure. All right, so one, all the commands are going to be serialized and executed sequentially. They're going to be executed in a certain order. And then two, either all or none of the commands will be executed. All right, so if you just stop and think of a bank account transfer, let's say you log into your bank account and you transfer money from one account to another, whether it's your own account or someone else's account. If in the middle of the two transactions, pulling from one, putting into one, if something happens and it breaks, you could just imagine the problems that would cause. All right, we'd have money disappearing left and right. So a transaction makes sure that both of those steps are going to happen or not happen. All right, it's either going to not do anything or it's going to complete the full transaction, get money from one account to the other. All right, a transaction in Redis is entered using the multi command. All right, at that point, users can issue commands and they won't be executed directly, but they'll be put into a queue where they'll sit until the exec command is called. All right, and then it will run all of the steps and run the transaction. Redis also has the ability to partition. Partitioning is the process of splitting your data up into multiple instances so that every instance will contain a subset of your keys. All right, now the advantage to partitioning is it allows for much larger databases. It uses the sum of the memory of multiple machines, and you can also combine the computational power of multiple cores and multiple computers. All right, so there's also different implementations of partitioning. There's client-side, there's proxy-assisted partitioning, and query routing. All right, but I'm not going to get into those right now. Just know that your data can be split up into multiple instances. All right, so the Redis command line interface is a simple program that allows us to send commands to Redis and also read replies sent by the server. And it runs in multiple modes. Interactive is the default. Just gives us basic line editing capabilities. We can run commands. We can also set it up to for slave simulation, as well as setting it up as a replication stream. But for the most part, we'll be using it in interactive mode. Okay, now Redis can be used with just about every popular programming language. It has a client for all of these programming languages here. You can see we have languages like C, C#, PHP, Perl, Node.js, Java, Objective-C, Python, pretty much anything you can think of. We'll be working in with the Ruby CLI directly with the database, as well as Node.js and JavaScript. Alright, so in this video I'm going to show you how to install and set up Redis on a Windows machine. Now I'm at redis.io/download, and the Windows version is kind of hidden, so we have to scroll down. We're not going to click this download. That's actually the package for Linux. So we're going to go to where it says Windows and click Learn More, and that'll take us to this GitHub page. And then what we're going to want to do is click this link right here that says Release Page, and this is the latest release at this time, 3.2.100. So we're going to grab the MSI file, which is a Windows installer. Alright, we're going to save that. Yours may be a different version. Okay, so we're going to run it. And it's just a simple wizard. We're just going to go through it real quick. Okay, the default location is Program Files Redis. That's fine. This right here, add the Redis installation folder to the path environment variable. I'm going to click check that so that we can run it from anywhere. The port is going to be port 6379. We're also going to add an exception to the Windows firewall. Click Next. Set max memory limit. I'm just going to leave that unchecked. And we're going to install. Okay, we'll click Finish. And I'm just going to open up a command prompt, command line, and we're going to navigate to C drive, program files, and I believe it's in Redis. Alright, now from here we're going to run Redis-server. Alright, now if we just run it like that, we're getting this warning that says no config file specified using the default config. In order to specify a config file, you want to add it along with Redis server. So we're actually going to say Redis server, and we're also going to say Redis dot windows dot conf. Okay. Let's see. Creating TCP server by no error. So now the server's running. Let's run Redis CLI. And now we're logged in. Okay, you can see the prompt has changed here. So we can do a little test here and say ping. And it gives us back Pong. Okay, so that's how we know that everything's connected and we're good. Now let's look at some command line basics here. Alright, so we can echo stuff out with echo. So actually it just put that in there for me, that's weird. I want to say echo, and we'll just say hello. Alright, so you can see it gives us back hello. We can also set variables. Let's say set, wow, this is new, this pop-up here, this code hinting or whatever this is. So I'm going to say set name, and let's set name to John Doe. Whoop. Actually, we can't do that. We have to do quotes John Doe. Alright. Now to get that, we can simply say get name, and it gives us John Doe back. Now we can check to see if something exists. So we can do that with exists, and let's say name, and we get a 1. If we say exists name 2, we get a 0 because there is no variable called name2. Now if we want to get rid of a value, if we want to get rid of the name there, we can say del name, and then we'll do exists name, and we get 0 because it's no longer a thing. We cleared it out or we deleted it. Now let's set another variable. We'll say set, and we'll call it count, and we'll set it to 10. Alright, so if we say get count, I don't really like that code hinting. Okay, it gives us 10. Now there's a function called inker we can use. So we'll say inker count, and you can see that it's now 11, so it increments it by 1. We can do it again. Now it's 12. We can also use decker, and now it's back to 11. Alright, so let's clear that out with del. Now I'm going to do a Control-C to escape from the Redis CLI, and I'm going to just type in here Redis-CLI, and let's say echo hello. And notice that even though I'm not inside of the Redis CLI, because I just typed it here and then I followed it with echo hello, it still works. Alright, so you can actually run commands without actually being logged into the CLI. Another thing we can do is we can monitor what goes on in the system. So if we go back in and say Redis-CLI and we say monitor, you can see that it just says OK, and then the prompt is gone. It's just kind of waiting. So we can open up another command line, and we'll navigate to that location. and we'll say Redis CLI, and let me just make that smaller, and let's say set, we'll say set foo bar, and you can see over here that it's set foo bar. So it's going to just basically just let the system know, or let us know, what is going on in the system. Alright, so if we say echo foo, you can see it says it over here. So this is monitoring everything we do. Alright, just another feature. Another thing we can do when setting variables is we can use a namespace. So if we say set, let's say set user :name, and we'll set that to Mike. Alright, and then we can say set user email. Okay, we'll set that, and then we can say get user name, and it gives us Mike. Okay, so we can set these namespaces. Another thing that we can do is we can set these values to expire in a certain amount of time. Alright, so let's take that user name for instance, and we can say expire user name, and then the number of seconds, let's say 100. Alright, so that's going to expire in 100 seconds, and we can actually check to see how much time is left. Okay, if we say TTL and then say user name, you'll see that there's 88 seconds left. Alright, if I do it again, now there's 81 seconds left. Okay, and if we say exists user name, you see we get a 1, but in 80 seconds or whatever, when it expires, it's going to go to 0. Alright, so we're going to go ahead and stop here. Just wanted to give you some basic commands and show you how to navigate around the command line a little bit. Alright, and I'll see you in the next video. Alright guys, in the last video we installed Redis and we looked at some command line basics in Redis CLI. Things like set, get, some of the really simple methods or simple commands. Now I want to go a little more advanced, not hard, but just a little more intricate than what we looked at already. Alright, so the first command I want to look at is flush all. And I want to run this first because this will flush all the variables, all the values that we have in memory. Alright, so anything that's left over from what we did in the last video will get cleared out. Alright, so let's take a look at mset. Okay, now mset it works just like set, except it allows us to set multiple values instead of just one. Alright, so for instance, let's say we want to set user, let's do username Bob, and then we'll say user email bob@gmail.com. Okay, so we get OK. Now if we were to say get user name, we get Bob. We can say get user email, and we get that. Now there's also a command called mget that will allow us to get multiple values. Okay, so if we say mget user name and user email, you'll see it returns both of those to us. Alright, now we also have a command called msetnx, and that works just like mset, except if something is already there, like let's say the username, and then it won't go through at all. So let me just give you an example. We'll say msetnx username Jeff, and let's say we want to set user city to Miami. Alright, now notice that it gives us a 0, and if we were to say get username, it's still Bob, because that command didn't go through because username already exists. Alright, if we were to say msetnx user city Miami, that goes through because user city wasn't there, username was. Alright, so that's msetnx. Alright, now I want to take a look at setX. Okay, in the last video I showed you how we could set something and then expire it. So if we say set foo bar, and then we could say expire foo in 20 seconds. Alright, we can say TTL foo, that tells us it's going to expire in 17 seconds. Now we can take this set and this expire and combine them into setX. So let's say set X, and then we could say foo, and we'll set that to 20, and then the value we'll say bar. Okay, so we're essentially just combining those two commands. Alright, and if we were to say TTL foo, we get 16. Alright. Now we also have psetx, which will set it in by milliseconds instead of seconds. Okay, so if we say psetx, let's say foo, and we'll say 30,000. Is that 30,000? Yeah. And then we'll set it to bar. All right. And then there's also a command called pttl, which will show us the number of milliseconds that is left, all right, before it expires. All right, so let's take a look at append. All right, now if I say exists, let's say exists greeting. Okay, that gives us a 0. We know that value doesn't exist. Now let's say append greeting hello. Okay, and that just returns the string length. All right, but now if we say get greeting, it gives us hello. So essentially it works like set in that situation, but we can now append to that value. So if we say append greeting, and let's put some quotes, and we'll put space world. All right, and now it gives us the number of characters for the entire value. So if we say get greeting, we now get hello world. All right, and you can keep appending to that if you'd like. Now we can also rename variables. So let's say we want to rename greeting. We could say rename greeting, and let's call it greet. All right, so now if we say get greeting, that's nil. Okay, it's nothing. If we say get greet, we get hello world. All right, we can also look for the string length with strlen greet, and that gives us 11. Okay, that's the length of the string. Let's see what else. We also have get set, and what that does is it will return what the current value is and then allow us to set it. All right, so let's say get set greet, and we'll say hi there. All right, now notice after I run the get set, it returns hello world, which is what was there before. If I were to now say get greet, it gives us the new value, which is hi there. All right, and then the last command I want to show you is get range. Okay, so we can get part of a string with get range. Let's say we want greet, and we want to get 0 to 4. All right, so you can see it gives us from the 0 index to the 4th. All right, let's say we want to do get range, and let's do 5 to 7. Oh, we got to say greet 5 to 7, and it just gives us ERE. All right, so that's get range. So those are some very simple string commands or key value commands, whatever you want to call them. All right, so hopefully you enjoyed this, and I'll see you in the next video. Hey guys, in this video we're going to be talking about lists and hashes. Okay, these are two very important data types in Redis. So we'll start with a list. A list is a group of strings. Okay, it's sorted by the order of which you insert the items. Elements can be pushed on the head or the tail of the list, so the front or the end, and they're often used as either producer or consumer queries. So the first commands we're going to look at is lpush and rpush. So lpush inserts a new element on the head, which is the left of the list. All right, so let's go ahead and let's say lpush, and then we want the key, which will be users. We're going to have a list called users, and let's give it a name. We'll say Jake. All right, so let's go ahead and run that, and we get a 1 back. So now we have a list called users with one element called Jake. All right, we'll go ahead and add another one. So we'll say lpush to users, and we'll say Tom. Okay, we'll do another one, lpush users and Fred. All right, you'll notice that it returns the number of items or elements in that list. Now, if we want to show what's in the list, we can't simply say get users. Okay, it says wrong type, operation against a key holding the wrong kind of value. What we need to do is use lrange. Okay, so if we say lrange users, we get wrong number of arguments. Okay, because we have to specify the range we want to find. So we want to start at the beginning, so we'll say 0, and then I want the entire list, so we'll say -1. All right, and you'll see that that gives us everything. If we want just the first two, we should be able to say lrange users 02. No, that doesn't work. Or 01, I believe. Users 01. And that gives us the first two because it's 0 base, so 0, 1, 2. All right, and of course, we don't have to start at 0. We can say users 1, 2, and that gives us Tom and Jake. Okay, it doesn't give us Fred. If we want to get the length of the list, we can use the len command. So that shows us that there's 3 elements in that list. Now, if we want to take an element off of the left side, we can use lpop. So we'll say lpop users, and it returns Fred, okay, which is on the left side. And now if we say lrange users 0, -1, you'll see that Fred is now gone. All right, so lpop will return it and pop it off. All right, and we can also use rpop, which will take it from the right. So now it takes off Jake, and if we were to lrange, now we only have Tom left on the list. So let's do another lpush to users, and let's say Sarah. All right, now we can also do rpush, which will add it to the right. Let's say Jill. And then we'll do an lrange users 0, -1, and you can see that we got Sarah we put on the left, Jill we put on the right. Now what if we want to put a user in between, let's say Tom and Jill? Okay, so that's not going to be left or right. What we can do there is we can use linsert. Alright, so we're going to say linsert users, and we want to say before, let's do before Jill, oops, before Jill, and let's say Kevin. Alright, let's try that, and then we'll do our lrange. And you can see we put Kevin in between Tom and Jill. Alright, so that's it for lists. Now we're going to move to hashes. And I just want to flush all, so we get rid of everything, and then let's clear this out. Now a hash is basically a map between string fields and string values. Alright, they are perfect for representing objects, and they're also very compact. So the first command we're going to look at is hset, which will basically just set a value in the hash. Alright, so we want to do hset, and for the key we're going to say user Brad, and we're going to give it a name, and we'll put my name in there. Okay, so you can see we get a 1 back. Now if we want to get that, okay, if we were to say get user Brad, we get that wrong type error. Alright, in order to get something from a hash, we need to say hget. So we'll say hget user Brad, and actually we have to specify the field we want. So hget user Brad, and we want to get the name. Okay. Now, if we want to set multiple fields, we can use hmset. Alright, so let's say hmset user Sam, and we want to set a name. We'll set that to Sam Smith, and let's set an email. Say sam@gmail.com, and let's also set an age, and we'll set that to 35. Okay, we get this okay. Now let's do hget user Sam, and let's say we want to get his age. Okay, so we can get that. If we do hget user Sam email, we can get that. Okay, we can also get multiple fields, but we have to use hmget. So we'll say hmget user Sam, and let's say we want name, age, email. Alright, and you can see that it'll return all of those values for us. We can also use hgetAll, which will get all values. So we should actually get the same thing here. Okay, and it actually gives us the key as well. Okay, name, email, and age. If we want to get just the keys, we can do that with hkeys. So say hkeys user Sam, and that gives us name, email, age. Alright, if we want to get just the values, we can use hvals. Okay, and that gives us all the values. Now we can also increment elements. So if we say h_by, and we want to do user Sam and do age, because that's the only number. Let's see, wrong number of arguments. Let's see, so we did h_by. Oh, we have to do the number. So let's try that again. We'll say user Sam age, and we'll do 1. Okay, and now you can see that the age is now 36. Now if we want to delete an element, we can use hdel. So we'll say hdel user Sam, and let's delete the age. Alright, so now if we say, let's do hgetAll, and now you can see that the age is gone. Alright, if we want to get the length, we can do hlen user Sam, and it tells us that there's 2 elements in that hash. Alright, so that'll do it for lists and hashes. In the next video, we're going to take a look at sets and sorted sets. Alright, so we talked about strings, hashes, and lists. Now we're going to get into sets and sorted sets. So a set is an unordered collection of strings. Alright, now we can add, we can remove, and we can test for existence of the elements in the set. And what's really unique about this is that a set cannot have repeating members. So you can't have the same string or the same element, same value inside of a set. Alright, so the first command we're going to look at is SADD, S-A-D-D. And before we get started, just make sure you flush all so that we don't have anything left over from the last video. So let's do SADD. Okay, and then we're going to need a key for our set. We're going to call this greetings, and then we're going to add a string of hello. Alright, you'll see it gives us a 1 back. Alright, so let's go ahead and add another greeting. We'll say sad greetings hi. And let's do greetings, and we'll say, I guess goodbye could be a greeting. Alright, so now we have a set with these 3 values. Now if we want to test if there's a given value in a set, we can use sysmember. So we want to say sysmember, and then the key is greetings, and let's say hello. Alright, so that gives us a 1 because hello is found. Now if we say sysmember greetings, and we'll say hi there, we get a 0 because that's not in that set. Now if we want to list everything that's in the set, we can use smembers. Okay, and that shows everything that's in the set. Alright, now as I said, there's no repeating values allowed. So if we were to say SADD greetings, and let's put something that's already in there, we'll say hi, we get a 0 back, meaning that nothing was added. And if we do smembers greetings, you'll see that hi is still only there once. If we want to find the number of elements or values in the set, we can use scard. Whoops. So we'll say scard greetings, and you can see it gives us 3 back. Alright, so what I'm going to do now is create another set. So let's say SADD, and let's call this greets, and let's put in a greeting hello world. Okay, so if we say members greets, we have hello world in there. Alright, now if we want to move a value from one set to another, we can do that with smove. So we'll say smove, and then we need the source, which is going to be greetings. Okay, and then we want the destination, which will be greets, and then we want the member. So let's move hello. Alright, so now if we do smembers greetings, you can see that hello is not there. If we say smembers greets, hello has been added. Now if we want to just remove something from a set, we can use srem. So we'll say srem greetings, and let's remove hi. Okay, so now if we say smembers greetings, oh, I spelled that wrong. Okay, now all we have left is goodbye. We removed hi. So let's just add a couple more to greetings. Okay, I'm going to put hello back. And we'll say hola. And let's say what's up. Okay, so if we look at greetings, we have 4 elements or 4 values. There's also a command called srandmember, and what that'll do, that'll just return a random value. So let's say greetings, and then we can have a count. So let's say we want 2. Alright, so that'll just give us 2 random values. We also have a command called spop, which is going to return a random value and then delete it. So let's say greetings, spop greetings, and then count will do 1. And you can see it returned goodbye. Now if we do smembers greetings, you can see that goodbye is now gone. Now if we want to take both of these greetings and greets and get the values from those, we can use sunion. So S union, and let's say greetings, greets. All right, and that just takes both and puts them together. If we want, and notice that hello is in both, so it only shows up once here. Now if we want, we can also say sdiff greetings and greets, and that'll give us let's see, that'll give us what is not in each one. So what's up in Ola. Alright, so that's sdiff. Now these are this is a set that we've been dealing with. Now sorted sets are basically just that. There's sets that can be sorted. Alright, so having an unsorted set can cause some problems in certain situations, and sorted sets aims to fix those problems. Alright, so every member or every element that is in a sorted set has an associated score, okay, which can basically be thought of kind of like an ID or a key. Alright, so this allows us to access data very quickly, and like sets, the elements in a sorted set may only appear once. Okay, you can't have repeating values. So what I'm going to do here is, let's say flush all, so that we can get rid of everything, and let's clear this out. Now when we're dealing with sorted sets, we're going to use a Z instead of an S. So for instance, instead of sad, we're going to use ZAD. Alright, so let's say that we want this sorted set, and let's call it users, and then we need a score. Okay, so a score has some properties. It's required. Okay, every element or every member in a sorted set needs to have a score. It has to be a number or a float. Okay, it can be a number or a decimal. A score is not unique. Okay, the values in the score are. So for this example, I want to use the user's birthdays as the score. Alright, so we're going to say ZAD users, and let's say 1981, and let's say Sam Smith. Okay, so that added a user, or Sam Smith, to the user's set, and it's the score for that element or that member is 1981, which is the birthday. Now let's go ahead and add a couple more. So we'll say ZAD users, and let's do 1984. We'll say Tom Carson. We'll say 1972. Ben Johnson. And let's do one more. And we'll do another 1981, and we'll do me. Okay, so to get the users in this sorted set, we're going to use zRange. Okay, just like we used lRange with lists, and we want to say users, and let's do start at 0 and -1, which means we want everything. Alright, and that gives us a list of these users. Alright, there's also zRange by score. Okay, zRange by score, users, and let's say 1981. Wrong number of arguments. Let's see. zRange users. Range by score. Oh, I think we need to include the 0 and the -1. So we'll say users. Let's see. 1981, 0, -1. No, that didn't work either. Oh, you know what? Maybe we don't need to include the score. Empty list or empty set. Alright, so Z-range by score is not working as far as I know how to use it. So, alright, let's skip the Z-range by score. Now, let's take a look at Z-rank. Alright, so Z-rank users, and let's do Sam Smith, and it gives us 2, alright, and the reason for that is because if you look up here, this is 0 base, so 0, 1, 2 is where Sam Smith is. If we were to say Z-rank users, and let's do the first one, which is Ben Johnson, we get 0. Alright, so that's what Z-rank does. It gives us the index. Okay, we also have Z-revrank. Let's say Z-revrank users Tom Carson, and that gives us 0. And it basically, it's doing it in reverse. Since it's the last one here, it's going to be 0. Alright, if we do Sam Smith, that should be 1. So let's try that out. Okay, that gives us 1. Good. If we want to get the total count, we can use zcard, okay, just like we used scard. That gives us 4. Let's see. And if we want to get the score of a member, we can use zscore users, and let's do Sam Smith, and that gives us 1981. Okay, that gives us his score. Alright, so we're going to go ahead and stop here, and hopefully this gives you a good idea of how sets and sorted sets work. So that's it, and I will see you in the next video. Alright, so what I want to do now is just briefly explain how data persistence works in Redis. Now, this stuff isn't needed for you to use Redis, but it's a good idea to try and understand how it all works behind the scenes. One key to being a good developer isn't just to memorize code, but to really understand what's happening. Alright, so here are some of the features that have to do with persisting data in Redis. Alright, so data is always initially stored in memory. This is what makes Redis extremely fast, both storage and retrieval. Now, in addition to an in-memory data structure, we also have the ability to persist data to the disk. And this is something that systems like Memcached can't do, or at least can't do easily. Alright, Redis uses something called forking, which is to create a child process which is an exact copy of the parent. Alright, so we can make changes and not affect the original data set. It uses what's called copy on write snapshot, which allows the system to fork the backup without us having to wait for it to complete. Okay, this all happens asynchronously. So let's take a quick look at the persistence process in Redis. So initially the client sends write command to the database. Alright, so the data is stored in the client memory. Then the database receives the write, and it's stored in server memory. From there, the database calls the system call that writes data onto the disk, and at this point it's in the kernel buffer. Alright, then the operating system transfers the write buffer to the disk controller, alright, or the disk cache, and then finally the disk controller writes to the physical media, or the physical disk. Alright, so that's a very, very brief summary as to what happens when data gets persisted to disk. Now, there's a couple different persistence options. We have RDB, which uses point-in-time snapshots. And I'm going to go over these a little more in a second. I just want to show you that there's a couple options. RDB, AOF, which is append only file. This uses write operation logging. We also have the ability to use both RDB and AOF. And then, of course, we have the option to disable both of them. And this is used for basically cache-only types of programs. So RDB stands for Redis Database File. And this is the simplest persistence mode, and it's enabled by default. Okay, it's a single file with a point-in-time representation of the data. and it works by using something called snapshotting, all right, which I'll get to in a minute. Now, some advantages of RDB is it's very simple to use. There's no initial setup or anything like that. It's very compact and lightweight. It's perfect for backup and recovery. Okay, it maximizes the performance of Redis. All it has to do is fork a child process, and the rest is handled asynchronously. All right, so it also allows for faster restarts with big data sets compared to AOF. So snapshotting is the process of creating an exact copy of a system or database that can be used to restore it back to a specific point in time. All right, the user can specify when and how often these snapshots will occur, and they can also be modified at runtime. All right, snapshots are produced as a file with a .rdb extension, and they're initiated with the save and the bg save commands. All right, so let's take a look at those commands. Save will perform a synchronous save of the data set, producing a point-in-time snapshot of all the data inside the Redis instance in the form of an RDB file. All right, it should not be called in production environments as it will block other clients. Instead, you want to use bg save in those production environments. All right, so here's an example here. So we have the save command, and then we're doing 60 and 100. So what this does is it'll dump the data set to the disk every 60 seconds if at least 1,000 keys are changed. All right, bg save, again, saves the database in the background, and the parent continues to serve clients. So bg save should be done in production. Some disadvantages to RDB: there's limited save points. It's not good if you want to minimize the chance of data loss if Redis stops working, and it needs to fork often, which can be kind of time consuming and can wear on CPU performance a bit. Okay, we also have AOF, or append only file, and this is much more reliable, and how it works is every operation that modifies the data set in memory gets logged. All right, so this creates an instruction set for the database. Now, logs are in the same format used by clients that communicate with Redis, and they can be piped to other instances. And the entire data set can be reconstructed using these logs or using this instruction set. All right, not everything is logged, only commands that will modify the data structure. Now, the log file or the instruction set is always growing. Okay, so when it gets too big, Redis will rewrite the entire database from scratch into a temporary file. Now, the rewrite isn't performed by reading the old one, but by accessing the data directly in memory. All right, so that way the shortest AOF file possible can be created, and it won't need disk access. Once it's written, it will then be synchronized to the disk. This stuff may seem a little complicated or hard to understand, but I'm just trying to give you an idea of how this stuff works under the hood. All right, Redis is a different animal than a disk-based database. So some of the advantages of append-only file: it's much more durable. It's only a single file with no corruption. It automatically rewrites in the background if it gets too big. Okay, everything's done asynchronously, so you don't see any performance hits. And it's easy to understand the logs and the instructions in the file. All right, so some disadvantages to AOF: it does take longer to load in memory on a server restart. It is usually bigger than the equivalent RDB files. It can be slower than RDB depending on the fsync policy, and there can be not too significant, but there can be some more bugs with AOF than with RDB. All right, now the best solution is to use both RDB and AOF for all right, so we're going to look a little into data persistence here. Now, I'm going to go to where I installed Redis, which is in my C drive, Program Files, and Redis. And there's a couple files that I want you to take note of. So one is the serverlog.txt file, and this is just exactly that, a log of everything that happens. You can see the server started here, It shows you when the forking goes on, when the database is saved to disk, basically everything that happens. All right, now the dump.rdb, this is the file I was talking about in the last video. When RDB saves data, this is where it goes. So let's open this up with Sublime Text. Now, it's not anything that is going to be readable to us. We don't know what's going on here, but it's actually saving data. Now, if I go into, let's go into our command line. Whoops. All right, and let's go ahead and just add, we'll create some variables. We'll say set key1 to hello, set key2 to something, key3 to foobar. All right. Now, if I go and I run save, I can actually run this manually, and then we click over here, you'll see that this file has grown. All right, so we persisted that data to the disk. And that's essentially how we can use RDB. Now and if we look at the server log, you'll see that it says DB saved to disk. Now for AOF, or append-only file, we need to go into our config file, which is, let's see, where is it? Right here, Redis windows.conf. I believe that's what we need. And there should be an option here for append-only file. So let's go ahead and search for that. Okay, so right here, append only. This is how we can enable AOF data persistent. Okay, we'll change that to yes. All right, and you can change the name of the file if you want as well. And let's see, for fsync, you have the 3 different modes here. The default is every sec, for every second. We're going to keep that. And I think that's really all we need. Rewrite min size 64 megabytes. Alright, so let's go ahead and save that. Okay, so I'm getting an access is denied errors, so I just need to change the permissions real quick. So I'm going to go to the file over here and do properties, security, and let's see, users, edit, and I'm going to give the users full control. Alright, so now if we go back over here and save, access is still denied. Alright, you know what, let's close it out, and let me just double check that. Users, oh, it didn't modify. Users, full control, apply. Okay. Alright, so let's search for append only and change that to yes and save. Alright, good. So now it's saved. Now I think we have to restart the service, so I'm going to go to my taskbar, which you can't see, my Windows taskbar, and I'm going to type in services.msc, and that'll open up this right here. And let's look for Redis, just right here, and we're going to say restart. Okay, so that should get restarted, and now let's go to the command line. Okay, and let's say Redis Redis CLI. Okay, and we'll just set foo bar. Alright, and now you can see that append only AOF is created, and if we look in that, you can see that we get this foo bar, and there's going to be some other stuff in here that you won't understand. It's just an instruction set to follow to recreate the database. Alright, so we know that RDB and AOF are now working. That's how data persistence works. There's more to it, but I'm not going to get too far into it. I just wanted to kind of give you an introduction to how that stuff works. Alright, so thanks for watching, and I'll see you in the next video. Hey guys, in this project we're going to be building a to-do list using Node.js, Express, and Redis. Okay, we're going to use the Redis client, which allows us to interact with the Redis database through our application. Alright, so I have it up and running now. You'll see that we have a couple to-dos here. Finish project 1, plan project 2. So we can add to-dos. Let's say call client 1. Click enter, and you'll see that gets added. And up in the console, you can see that we get to-do added. Alright, if we want to remove them, just click on the checkbox, remove, and it goes away. Alright, now we can also use the Redis command line here. I'm in the Redis CLI, and if we say lrange to-dos 0, -1, you'll see it fetches the to-dos. We can also add them from here. So we'll say lpush to-dos, and let's say test to-do. That gets added. Now if I go over here and reload, you'll see it also gets added to the application. Alright, so that's what we'll be building. Hopefully you enjoy it, and I'll see you in the next one. Alright, so we're going to get started on a to-do list application using Node.js and the Redis client. Alright, so you need to have Node.js installed. I already have it installed, so I'm not going to go through it, but all you need to do is go to nodejs.org, go ahead and download it, go through the installer, and get that set up. Alright, so first thing I'm going to do is create a project folder in my C drive in the projects folder, and let's call this Redis to-dos. And I'm going to just open up a command line into that folder. Alright, so let's navigate to it. Projects, Redis to-dos. Alright, so we need a package.json file, alright, which is a manifest that'll have the application name, the version, and all the dependencies. So to create that, we can say npm init. Alright, and that should just pull up some questions. So the name of the application, Redis to-dos, we're just going to enter through these. Version, description, we'll just say simple to-do list. Entry point, let's do app.js, and then just enter through the rest. Alright, and then we're going to add the project to our editor, which is Sublime Text. Alright, so you can see that that created a package.json file, and if we look at that, it just has the information we just added. Now what we want to do is install our dependencies. So let's go down to our command line, and we're going to say npm install, and we want to install a couple things. We want Express, which is a web framework for Node.js. We want body parser. We want EJS, which is a template engine, and we want Redis. Okay, now let's add -- save, and that'll save all of them to that package.json file. Alright, now if you look at package.json, you can see that all the dependencies are now listed in there. Next thing we're going to do is create the app.js file. Okay, and we're going to bring in some stuff. We want to bring in Express, so we're going to require that. Okay, let's bring in the path module, which is a core module. Okay, let's bring in body parser. Okay, and then we want to bring in Redis. Okay. Now we're going to create our main app variable and set that to Express. And then let's set up our view engine. Okay, so we'll do app.set, say views, and now we're going to use that path module to call path.join, and we want _dir name. And what we're doing here is just telling the system that we want to use the views folder for our views, which we'll create in a second. Alright, then we just need to set the view engine, so we can do that with app.set view engine, and we're going to set that to EJS, which is embedded JavaScript. Alright, so let's add the body parser middleware. This is just standard. Say body parser.json. And we also want body parser.url encoded. And we just want to pass in here an object and say extended false. Okay, that's just standard body parser middleware. Alright, now we want to have a folder that's going to be static. Okay, that's where we want to put any style sheets or front-end JavaScript, anything like that will go. So we need to tell the system what folder we want to use for that. So we'll say app.use, and in here we want to say express.static, okay, and then path.join, and the folder that we're going to use is going to be called public. Okay, that'll be our static folder. Alright, now let's just create a simple route for the home page with app.get. Okay, so that'll handle a GET request to /, which is the home page. Okay, and then we'll put a function here. Just a standard Express route. And this function is going to take in a request and response object. And then all I'm going to do for now is just say res.send. And we'll just say home. Okay, now we need to say app.listen, and let's listen on port 3000. And then we're just going to add a callback function here because I just want to do a console log. Okay, we'll just say server started on port 3000. Okay, and then finally we're just going to say module.exports equals app. Alright, so let's go ahead and save that, and then we're going to go to our command line and we're going to run node app. Okay, you can see server started. So if we go to HTTP localhost 3000, you can see we get home. Now to connect to Redis, we should be able to, let's see, we'll go right here and let's say var client, and we'll set it to redis.create client. Okay, and then we're going to take that client and call .on. Okay, we want to say .on connect. Then we'll have our function, and let's just do a console.log, and we'll say Redis, connected to Redis. Alright, let's try restarting the server. Alright, so now we're connected to Redis. So we're going to go ahead and stop here, and in the next video we're going to open up our Redis CLI and we're going to add some tasks or to-dos, and then we want to be able to pull those into our application, alright, and then ultimately display them in the browser. Okay, so we'll get to that next. Alright, so we have our server created, our Node and Express server, which right now is just serving up home from the home route. Alright, we also have our Redis client connected. Okay, we're not doing anything with it, but it is in fact able to connect. Alright, so if we go ahead and we say node app, you can see that that runs. Alright, now in this command line here, I have it in the Redis program files folder, and I'm just going to run Redis CLI. Alright, and let's make sure everything's flushed. So we'll say flush all. And what I want to do is just create a to-dos list. Alright, so if you remember, when we're working with lists, we can use a command called lpush. And we're going to say lpush to-dos, and for the value here, let's say start, we'll say start project 1. Alright, so let's add another one. To-dos. Oops. Don't need that. Okay, so lpush to-dos, and then we'll say call client 1. Okay, we'll add one more. Let's say plan project 2. Alright, so now we have these to-dos, and we can view them by saying lrange to-dos 0 -1. Alright, so there's our to-dos. Now the idea is to pull these into our application, alright, and then display them in our view. So let's go to our route right here, where right now we're just sending out the text home. What we want to do is render a view. Alright, so instead of res send, we're going to say res.render, and we want to render, we're going to render index. Alright, now let's save that, and then we have to go over and create our views folder, and inside there we'll create a file and save it as index.ejs. Okay, remember we're using the EJS template engine. Alright, so in here let's say, let's put an H1. Okay, save that. Let's restart the server. And now let's go over here and reload, and we get my to-dos. Alright, now we can send values to, we can send dynamic values to our view from here if we want. So let's say we want to create a variable called title and set that to, let's set it to Redis to-dos. And then if we want to send that over, we'll put another parameter here, which will be an object, and let's say title, and we'll set it to that title variable. Alright, and then in the view, we can access it using this syntax, just like that. Save it. Let's restart. Alright, now a good trick to this, if you don't want to have to keep restarting, you can use something called nodemon, which you can install globally using npm. So we'll say npm install -g nodemon. Alright, this will allow it to watch our file, our app.js file, and update it when we save the file. So let's go ahead and run nodemon. Alright, so now it should be watching it. Let's reload, and now we get Redis to-dos. Alright, and I should be able to change this. Let's say Redis to-dos 1, save, and you see I don't have to restart the server anymore. So what we want to do now is we want to fetch those to-dos from Redis. So let's go ahead and we're going to go right here and let's say client dot lrange. Okay, now we can use the API just like we would in the terminal or the command line. We want to specify the list we want, which is to-dos, the range, which will be 0, -1, and then we'll have our function. Okay, this function will take in an error and a reply, and then what we'll do is take this render right here and cut it and put it inside there. Okay, and then we just want to send along tasks, and we'll set that to reply. Alright, actually that'll be to-dos, not tasks. Alright, so now we should have access to this to-dos inside of our view. Now, since this is a list, we're going to have to loop through it and then output each list item. So we're going to use our EJS syntax here. And in here we'll do to-dos dot for each. Okay, and inside the for each right here, we're going to put a function. Alright, now this part of it we're going to cut that out and put that down here inside of our tags. Just like that. Alright, and then in here we'll put in to do, and we should be able to access each individual to do. So let's put a div. Okay, and then in here we should be able to say to do. Alright, now we put the equal sign because it's an output. When you're outputting something, you use the equal sign. We didn't use it here because this is just a for each. We're not actually outputting with that line. So let's go ahead and save that and cross our fingers. And there we go. So we're pulling them from Redis into our application. Now I do want to make this look a little better, so we're going to use Bootstrap. But I want it to be kind of customized, so we're going to go to bootswatch.com, which gives us free Bootstrap themes. And let's grab Sandstone. So click download, and then I'm just going to grab this link here, copy it, and then what we're going to do is we need to create the rest of our HTML structure. So let's put our HTML tags. Let me actually format this as HTML. Alright, so we'll do our head, body, okay, now we're going to put in a link, style sheet, href, and let's paste that Bootstrap link in there. Alright, so we'll save that. Okay, and let's go ahead and add a class to this div, class of well. Okay, and we're also going to add a container around this. Okay, and for the H1, we'll add a class of text center. Okay, so we have our to-dos. Now if we were to go to our command line down here and say lpush to-dos, and let's say finish, oops, finish project 1, and then go and reload, there it is. Alright, so in the next video I want to make it so that we can actually add to-dos through our application. Alright guys, in this video we're going to make it so that we can add to-dos through the application. So first thing we're going to do is create a form. So let's go right above or right below the H1, and let's create a form, and I'm going to give this actually no, we don't need to give it a class. Let's give it a method of post and then an action, and the action is going to go to, let's say, /to-do/add. Alright, and then let's put an input, and we'll give it a type of text and a class of form control, and let's also give it a name of to do. Okay, and a placeholder. Alright, so let's go ahead and save that. Okay, so there's our input. Now we're submitting to the route to do add, so we need to create that in our app.js. So let's go over here and say app.post, since it's a post request, and it's going to be /to-do/add. We'll have a function here. This will take in a request, response, and next. Now we want to get the value from the form, so we'll put that in a variable called to do, and we can get that with request.body.todo. Alright, and then all I want to do is console.log for now, just to make sure that it's actually going through. So let's save that, and we'll reload, and let's say test to do, enter. Take a look at our console, and there it is. Okay, so we know that it's coming through. Alright. So all we have to do is take that client and call .rpush. Okay, we want to push it on the right. We want to push it to to-dos. Okay, and we're just going to pass along that to-do variable that we created, and then our function. Okay, again, the function will take in error and reply, and let's test for the error. Okay, so if there is an error, then let's just do res.send, and we'll send it along. Alright, we didn't do that up here. Let's actually copy that and put that here as well. Alright, now if there's not an error, then let's just do a console.log. We'll say to do added, and then let's do a redirect with res.redirect, and we'll go back to our home page. Alright, let's save it and let's try it out. Okay, so we'll say call client to, enter. Okay, it looks like we might have an issue. Alright, let's take a look at the console, see if that gives us anything, which it doesn't. Alright, so let's see if anything changed inside the list. so it didn't get added there either. Huh. Alright, you know, I'm just going to restart the server. I know we're running node mon, but I'm going to restart it anyways. Alright, let's just check this again. So we know that this is going through. It's getting put into do. And then we're taking client.rpush. We're pushing to to-dos, and we're pushing the to-do value that's coming in. Then we have our function, which takes an error and a reply, checking for the error, and then we're just console logging and then redirecting. So the issue seems to be right here. But that does look okay, so let me just try this again. Okay, so I guess this, for some reason, the server did need to be restarted because it's working now. If I reload, it's still there. Good. Alright, so in the next video, we'll make it so that we can delete these list objects or these to-dos. Alright, so we can now add our to-dos and we can read them from Redis. Now I want to be able to delete them. So I want to have a checkbox next to each one. So we're going to go into the view, into the index EJS, and we're going to wrap, let's see, we're going to wrap this, let's see, this entire thing in a form. Alright, so form method is going to be post. Action is going to be /to-do/delete. Okay, let's close that down here. And I want to put, let's see, let's put inside here an input with the type of checkbox. Okay, we'll say name equals to-dos. Let's give it a class of delete and a value of to-do. Wait, is that right? Yeah, that should be good. Let me just make this wider. Alright, so value, let's save that. Okay, so now each to-do now has a checkbox. So let's go to app.js now. And we're going to create another route. This is going to be a post, so app.post. And it's going to be /to-do/delete. Okay, this will get request, response, next. And in here, we're going to create a variable called del to-do. So this will be the to-do that we want to delete. So we'll set that to request.body.todos. Alright, or actually let's say del to-dos because it could be more than one. And then we're going to do client.lrange. We want 0 to -1. And then have our function, and for that we'll say error, reply, and let's say we're going to do a for loop because we want to loop through each one. Let's actually change this reply to to-dos. That makes more sense. Alright, and then we'll say for var I is equal to 0, and we're going to say as long as I is less than todos dot length and then I plus plus. Alright, and then in here we want to check the delete, the del todos. So we're going to say if del todos dot index of, and in here we'll say todos, and it's going to be the current iteration, so put the I in there. Alright, and we're going to say if that is greater than -1, then we know we want to remove that or delete it. So we can say client.lrem todos, and we want to put in 0, todos I, whoops, and then our callback function. Alright, and then in here, let's check for the error. We'll say if error, then we'll just console log it. Okay, and then we want to redirect, but we want to do that way down here after the for loop. Okay, we want to redirect to the home page. So let's save that. Alright, and let's see, one thing that I did forget is the submit button for the delete form. So in the index EJS, let's go, let's see, we want to go outside of the loop, which ends here, and we'll put in input type equals submit, value equals remove. Alright, now I'm going to go and restart the server just in case. Okay, reload, and let's say test to do remove, and there it goes. Okay, let's make sure we can delete more than one. Awesome. So we can now add to-dos, we can remove them, and of course we can read them. So that's going to be it for our application. I would suggest maybe keep going further and add some other functionality to it. Basically, you have the entire API available to you, just like you would in the command line. All the commands that we've gone over in past videos you can use here as well. You can create hashes, you can create sorted sets, whatever you'd like. Alright, so hopefully you found this project useful, and thanks for watching.